Welcome to Deployment and DevOps. Efficient deployment and automation are essential for building scalable, reliable applications. Understanding how to streamline workflows, secure cloud environments, and optimize performance will help you develop and maintain robust back-end systems. By the end of this course, you'll be equipped with the skills to enhance software delivery and efficiency in real-world DevOps environments. We will begin this course by exploring how to deploy applications to Azure and examining how cloud services enhance scalability, security, and performance. We will then break down deployment processes, security best practices, and strategies for managing applications in a cloud environment. Next, you will set up CI/CD pipelines using GitHub Actions and Azure DevOps. Learning how to automate simplifies integration, testing, and deployment. You will explore best practices for monitoring and maintaining pipelines to ensure smooth and reliable software delivery. Then we will focus on application monitoring and maintenance, identifying proactive strategies to track performance, manage logs, and automate routine tasks in Azure. You will also explore techniques for maintaining long-term application stability and security. After that, you will use Microsoft Copilot to automate deployment scripts and CI/CD pipelines, discovering how AI-driven assistance streamlines workflows, enhances debugging, and optimizes DevOps processes. Finally, you will apply everything you've learned in a final project, integrating deployment automation and monitoring techniques to create a complete DevOps solution. By the end of this course, you will have the knowledge and skills to deploy, automate, and maintain applications with confidence. We look forward to guiding you through the key principles of deployment in DevOps and helping you build efficient, scalable, back-end solutions. Let's get started.
My name is Paul Party, and I'm your instructor for this course. I've been programming computers since I was in my teens. I love programming because it's like solving puzzles while designing and creating something amazing. My graduate degree is in philosophy, where I learned how to become a better thinker. When I program computers, I can apply many of the logic skills I learned in philosophy. Computer programming not only enables you to build cool software, but I believe it can help make you a better thinker. I started my software development career at Microsoft when the internet was just getting started, and I participated in the internet revolution firsthand. I managed software engineering teams that worked on desktop and web-based software. The internet gave software developers, particularly those working on user interface, incredible new opportunities. From mobile interfaces to websites, software developers are not only creating software that's functional, but also works of art. In my career, I managed and worked with teams at both Microsoft and PayPal that focused on customer-facing interfaces and learned how to make them great. I also spent part of my 20 years at Microsoft in training organizations where I learned how to communicate challenging ideas to new learners. I also was fortunate enough to have spent 15 years teaching non-majors philosophy at a university in Seattle. This reinforced my ability to teach learners difficult concepts using ideas they can relate to. There's nothing more satisfying than to witness a learner having an aha moment where they understand something new. I'm really excited about this program. I believe Microsoft has some of the most powerful and exciting software development tools available, and I can't wait for you to learn about them. I'm confident you'll have many of the aha moments as you gain new skills and reinforce existing ones. The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material. They're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. All right, I think I know this one. I'm going to type in INT and hit Enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click Continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select Enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click Continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select enter to check your work. I'm not totally sure here, so I'm going to click on hint and get some help. And the hint says use console.readline and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or U-try-its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel challenged, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development. Throughout this program, you will develop the foundational skills required to build a robust, real-world backend system. Now it's time to bring everything together in your Capstone project. In this project, you'll build the backend for an order management system designed to manage inventory and customers across multiple fulfillment centers. You'll create a professional-grade system. You'll integrate business logic, develop secure and efficient API endpoints, apply authentication and authorization, and optimize performance using modern development tools. In the first part of your project, you'll focus on structuring the core business logic. This stage involves creating classes to represent inventory items and orders, modeling data relationships, and connecting to the relational database using Entity Framework Core. Object-oriented programming helps organize this logic in a clean and scalable way. Next, you'll build a RESTful API to expose this data. You'll create controllers and define routes that allow other systems to view, create, and delete records through HTTP requests. This makes your application data accessible and ready for integration. Once the API is functional, the next step is securing it. You'll implement user registration and login using ASP.NET Identity and protect sensitive routes with role-based authorization. These measures ensure that only authenticated users can access or modify critical data. After securing access, it's time to focus on optimizing performance. You'll apply caching and optimize database queries to make the system more responsive and scalable. Microsoft Copilot will assist by analyzing your logic and suggesting improvements to increase efficiency. In the final stage of your Capstone, you'll ensure consistency and reliability across user sessions. You'll integrate state management techniques, validate the full system through testing, and use Copilot to refine and finalize your code before submission. Your Capstone project is a chance to demonstrate your ability to design, build, and secure a complete back-end system. This is your opportunity to showcase everything you've learned in this program. We're excited to see what you create. Good luck and enjoy the process.
Welcome to Deploying Applications to Azure. In this module, you'll learn how to leverage Azure Cloud Services to deploy, manage, and secure applications efficiently. We will begin by introducing Azure Cloud Services, highlighting their key features and advantages in modern application development. You'll gain an understanding of how Azure supports scalability, security, and efficiency in cloud-based solutions. Next, we will explore the essential steps to prepare applications for deployment to Azure, covering configuration, compatibility checks, and performance considerations to ensure a seamless transition to the cloud. Then we will examine the deployment process for web applications in Azure, breaking down different deployment methods, tools, and best practices to streamline application launches. After that, we will discuss strategies for managing and securing applications in Azure, focusing on monitoring, access control, and compliance to maintain stability and security in a cloud environment. Finally, we will review best practices for securing applications on Azure, identifying common security challenges, and explore effective techniques for protecting applications from potential threats. By the end of this module, you will have the knowledge and skills to deploy, manage, and secure applications on Azure with confidence. Let's get started with deploying applications to Azure. Cloud computing eliminates the need for users to manage the underlying physical infrastructure, allowing for simplified data storage, scalable computing power, and access to various software and platform services. With a cloud platform like Microsoft Azure, you can efficiently organize, deploy, and scale applications, turning innovative ideas into reality. In this video, we will identify the core infrastructure and services provided by Azure for deploying and managing applications. Let's begin by exploring some of Azure Cloud's key features, starting with its offering of virtual machines. Virtual machines are software-based simulations of physical computers that run an operating system and applications independently from the host hardware. Virtual machines offer flexibility and scalability, making them ideal for cloud computing, software testing, and disaster recovery, by allowing easy replication, backup, and migration. For example, a small business could use virtual machines to test a new app in different environments without investing in physical hardware. In addition to virtual machines, another key feature of Azure Cloud Services is app services, which helps simplify the process of deploying and scaling web applications. App services are a fully managed platform as a service, or PaaS, provided by Azure for building, deploying, and scaling web apps and APIs. It offers a variety of services to simplify the development and hosting of applications. For example, imagine operating an online store. Because you are using Azure Cloud Services during a major sale, app services will scale automatically, adjusting resources based on demand to manage increased traffic, ensuring your customers have a smooth shopping experience. Azure Cloud Services also has Azure Functions, a serverless computing feature that allows you to automate tasks and respond to events. Serverless computing is a cloud computing model where developers can run applications without managing servers. Unlike Azure App Services, which continually host full applications, Azure Functions only executes code on demand, responding directly to specific events or triggers. This allows you to execute code in response to events without the need to manage servers or handle scaling. For example, if you need to process data as soon as it's uploaded to your storage, Azure Functions can ensure the task runs immediately without requiring a dedicated server, automatically scaling based on demand. This enables seamless automation for tasks like data transformation, validation, or integration with other services, improving efficiency and reducing infrastructure overhead. A final key feature of Azure Cloud Services that helps you manage other resources is resource groups. In the context of Azure Cloud, resource groups are logical containers that help you organize and manage related resources, such as virtual machines, storage accounts, and databases, to be managed as a single unit. For example, imagine a development team working on a new app. They could group all the required resources, like virtual machines, database, and storage, into one container, which we consider a single resource group. This way, tracking and updating your various resources becomes more straightforward and more efficient. In this video, you were introduced to some of the core infrastructure and services provided by Azure Cloud Services for deploying and managing applications. Azure's infrastructure services are the foundation of many modern cloud applications. By learning these tools, you're building the knowledge needed to turn ambitious ideas into scalable, efficient solutions.
Web applications need to respond quickly and stay available, no matter how many users connect or where they connect from. Azure includes built-in features that help applications perform well and remain online, even during traffic spikes or unexpected issues. In this video, we'll explain how Azure ensures scalability and reliability for web applications. To begin, let's explore some of the scalability and reliability mechanisms offered in Azure, starting with autoscaling. Autoscaling is a cloud computing feature that automatically adjusts computing resources based on real-time demand. It helps maintain performance during traffic spikes and reduces costs during low usage by automatically adding computing power when more people use the app and scaling down when demand drops. Azure Virtual Machine Scale Sets, also known as Azure Scale Sets, allows you to deploy and manage a group of identical, load-balancing virtual machines that can autoscale to meet application demand. For example, a developer building a food delivery app may expect traffic to spike during lunch and dinner hours. To manage this, they configure Azure Scale Sets with virtual machines so the app automatically adds more servers during peak times to maintain smooth performance. When traffic slows down late at night, the system scales down, helping reduce costs without any manual effort. Another mechanism is Azure's ability to distribute traffic efficiently across servers, which is managed through load balancers. Load balancers are tools that distribute incoming network traffic across multiple servers to ensure no single server gets overwhelmed. This helps improve application reliability by preventing server overloads and enhances performance by directing traffic to the most responsive servers. Azure Load Balancer distributes incoming traffic across virtual machines to help ensure high availability and reliable performance. It automatically routes traffic to healthy virtual machines when others become unavailable. For example, a developer building a multiplayer gaming platform needs to handle large volumes of user connections smoothly. They use Azure Load Balancer to distribute traffic evenly across multiple game servers, ensuring no single server gets overwhelmed, and players experience low latency gameplay. Beyond performance, Azure also makes formal promises about keeping your app available, known as Service Level Agreements, or SLAs. Service Level Agreements are formal commitments from a service provider that defines the expected level of service, such as uptime, performance, or support response times. They often include specific metrics and outline what compensation is provided if those targets aren't met. Microsoft Azure's SLAs guarantee that its services will be available and running smoothly for the vast majority of the time, typically 99.9% to 99.99%, depending on the service. If these availability levels aren't met, customers may receive service credits as compensation. For example, for a developer running an e-commerce site on Azure, this means the site is expected to stay online almost all the time, even during busy shopping periods. If Azure fails to keep the service available as promised, the developer may receive a credit to reduce their next bill. In this video, you learned how Azure ensures scalability and reliability for web applications.
Understanding how Azure handles scalability and reliability helps you make smart choices when building and deploying web apps. These features form the foundation for applications that stay fast, available, and resilient in real-world conditions. Building a successful application involves more than writing great code. It's also about preparing it to run securely and efficiently in different environments. By learning to configure, manage, and build your app, you set the stage for reliable and seamless deployments. In this video, we will explain how to prepare your applications for deployment using Visual Studio Code and open source tools. To begin, let's explore the key tasks involved in preparing and configuring applications for deployment, starting with managing environment variables. Environment variables are key value pairs used by an operating system to store configuration settings that applications and processes can access. They help manage system-wide or application-specific settings without hard-coding values into the code. .env files are commonly used in development to manage environment variables. However, different systems and platforms handle them in various ways. To begin configuring environment variables, navigate to your project's directory in the Visual Studio Code terminal and install the required library by running .NET add package .NET-ENV. Next, create a .env file in your project folder using Visual Studio Code. Then, inside the .env file, add variables such as API key equals 12345 secure. Finally, in your program.cs file, use the env.load method to load the environment variables from the .env file. This method reads key value pairs from that file and makes them available to your application at runtime. It helps separate sensitive data from the source code, reducing the risk of exposing credentials in repositories or logs. The env.load also allows for environment-specific configurations without modifying the code, ensuring flexibility across development, testing, and production setups. Now that we've explored the configuration task of managing environment variables, let's examine how to manage dependencies in your application. Recall that dependencies are pre-built libraries that add functionality to your app, such as handling JSON data. Dependency management is the process of adding, updating, and maintaining external libraries and packages, often using tools like NuGet. To start managing and configuring dependencies, open VS Code and use its terminal to install any needed dependencies. For example, in VS Code terminal, you can run .NET add package newtonsoft.json to add a package. And to ensure all dependencies are up to date, run .NET restore. This approach ensures compatibility and functionality in your application. Now that we've explored how dependencies are managed, let's examine how to configure the build for your app and ensure it's ready for deployment. A build configuration is a set of predefined settings and rules that dictate how a software project is compiled, packaged, and deployed. It defines aspects such as the target environment, optimization level, dependencies, and build scripts. Configuring your build compiles your application into executable files and identifies any errors in the process. For example, in the VS Code terminal, run .NET build to generate the compiled files in your project/bin folder. This folder contains the compiled binaries, dependencies, and necessary files for running the application. After the build completes, check the terminal output for any errors or warnings. If the build is successful, you can find the executable files in the /bin/debug/netx.x directory, where XX represents the .NET version. These files allow you to test the applications locally before deployment. In this video, you learn the key configuration concepts for preparing applications for deployment using Visual Studio Code and open source tools. Getting your application deployment ready is about building a secure, efficient, and reliable foundation for any environment. Cloud deployment starts long before you push your code. Preparing your application for the cloud ensures it runs securely and predictably, no matter where it's deployed. By handling settings, credentials, and packaging early on,
you'll be well prepared for a successful deployment. In this video, we'll explain the steps to configure applications for deployment to cloud environments like Azure. Let's start with configuring an app's behavior using application settings. In the context of Azure App Services, application settings are key value pairs used to configure app behavior without modifying code. They are accessible as environment variables at runtime, allowing for secure and flexible management of things like API keys and environment-specific values. For example, you might want your app to give detailed error messages when developing locally, but hide them from users in production. On Azure, you can create application settings for your app in the Azure portal, then call them from your application. The settings are stored securely in the cloud and aren't a part of the source code. When developing your app or testing locally, you can use a local.env file to store the same settings you create in the cloud. This enables you to mimic the behavior of the application settings you'll use when you deploy your app to Azure. After configuring application settings, the next step is to configure how your app connects to external databases using connection strings. Connection strings are strings of text used to specify how an application connects to external resources like databases, storage accounts, or message queues. They typically include details such as the server address, database name, username, and password needed to establish the connection. While they're commonly used for database connections, they can also connect to other services like storage accounts, cache services like Redis, or message queues. Similar to application settings, connection strings should be stored securely and managed separately from your code in cloud environments like Azure App Services. For example, instead of including the database credentials in the application code, developers store the connection string in Azure App Service settings, which the app reads at runtime. This makes deployments more secure and easier to manage. Once your app is configured and database connections are in place, the next step is to ensure it runs the same way everywhere, which is where containerization can help. However, before we explore containerization, we need to examine what a container is and how it fits into the containerization process. Containers are compact, self-contained units that include an application and everything it needs to run, such as libraries and system tools. It's lightweight because it only uses the essential parts needed to run the app, relying on the host system for the rest, which makes it fast and efficient. Containerization is a method of packaging an application together with all its dependencies, libraries, and configuration files into a single container. This ensures the application runs consistently across different environments, such as development, testing, and production. In Azure App Services, the containerization step involves deploying custom Docker containers or container images from the Azure Container Registry or Docker Hub. Docker is a platform that enables developers to build, package, and run applications in containers. It simplifies deployment by ensuring the application behaves the same in any environment, from a developer's laptop to production servers. For example, a developer uses Docker to prepare their application with everything it needs to run into a container. They test the container locally to make sure it works as expected. Then they deploy the same container to a cloud service like Azure, ensuring the application runs consistently across environments. In this video, you learned about the steps to configure applications for deployment to cloud environments like Azure. By preparing your application with cloud-aware settings, secure external connections, and consistent packaging, you've created a foundation for reliable deployment. These steps turn code into something that performs dependably in real-world environments.
After you've developed an application, the next step is to deploy that application to a cloud service. So in this screencast, we're going to demonstrate the steps to configure applications for deployment to cloud environments like Azure. So I have a simple .NET API application here, and there's various files that we're going to look at and how they function in this environment. But the first thing I want to demonstrate is how we set up our environment variables so that we can use them both in a local context and on the cloud context. Many times you have some pretty private information that you want to keep stored, like API keys. You don't want those published or necessarily built in as a part of your application code. or you have other key value pairs that change depending on the environment, or they're changing constantly, and you don't want them embedded in your code itself. So what you want to do is create a situation where you store those key value pairs separately from your code. And cloud environments like Azure allow you to create a secure location where you can store that type of information. I'm going to switch over to the Azure portal. And I have an application here. This is a web app that will illustrate and demonstrate the ideas that I'm talking about. And in this web app, Azure provides under settings this environment variables category. These are the settings and the different things I can do for this web app. And under settings, I have this environment variables category. And here I can set up certain key value pairs. So for example, if I have an API key that I don't want to embed in my code, I don't want it to be a part of my code base, I can store it here, and this is a secure location, so only people that have access to this web app as an administrator can view these key value pairs. But the application also can view them once it's been deployed to the cloud. So it's secure because the API key now is not a part of my code base. I don't have to check it into source control. It's stored distinct from my application, but I can also access it very easily when it's deployed to Azure using code that we can write in our application. So I create these key value pairs on Azure, and then I can use them in the app. The problem is that if I want to test locally, I have to be able to store those key value pairs as well in my application so that when I'm actually testing on my local machine, I can access those same key value pairs. So to do that, I'm going to use this library called .NET-ENV, and that allows me to create this .env file. And in this .env file, I can create those same key value pairs. And I can leave this .env file just on my machine. I don't have to check that into source control, but I can use it for testing. So those key value pairs are available to my app while I'm testing locally. And then when I push the application to the cloud, let me go back to Azure. It will use these versions of those same key value pairs. You can see I have API_key here, ASP.NET Core_environment here, and I've got those same two key value pairs here. And obviously I can create as many key value pairs as I need for my application to run. And I only want to really create this type of data for items that I don't want as a part of my source code. That's one way that you can prep your application for delivery to the cloud, is to figure out what that data is. Make sure you have that data in your cloud environment, and then also be able to work with it locally. The other thing we can do that's also very important to keep secure is a database connection string. At the top of my file here, I am creating this variable called configuration, which is on the builder.configuration object. And we create the variable called connection string and set it equal to configuration.getConnectionString method. I'm calling default connection as the connection that I want to get. In this environment that I have set up, I'm using the default connection key value pair that's also in Azure. Let me go back to my Azure application to show how this works. In Azure, under the same settings environment variables, there's a tab called connection string. So the tab we were in was app settings. Now we're going to switch over to connection string. I have that default connection key value pair here. This is what that line of code will call. And I can also set this up so I can test it locally so that there's a default connection on my local machine, but it will call this default connection. And in a connection string, there's typically a username and password, which I don't want to expose over an internet call or put it into my source code. So I can keep that default connection and the valuable data that's in it outside of my source code. And it just is kept here locally on the server and never gets transferred back and forth between the client and server when I'm running that application. So that's another way that I can prep my application for delivery to the cloud by creating your connection strings to your databases using Azure Portal and then call them from your application code. Here I'm creating my DB context, which is a SQL Server connection. If I switch back to the Azure Portal, I can show this value. I actually didn't put a value in there, but I have the type as SQL Server, and then I can put my username and password as the value. And then I'm using that, and when I create my application DB context and the options to use SQL Server, passing in the connection string information so that I can communicate with the database that's on Azure when I'm ready to interact with it. So the first step is to create some app settings using the environment variables. The second step is to create that connection string for when I want to interact with the database. The third thing I can do is to containerize the application with Docker. Docker allows me to wrap the application and all of its dependencies into an isolated environment that doesn't require a full operating system. I can create as many copies of that container as I want, and then I can run them independently in a Docker environment, and they act like little servers. They act like little programs that run my application within that consolidated environment. So Docker is a very powerful tool for creating multiple instances of your app to do different things for different purposes. So one of the things I can do is use Docker within my application to deploy to the cloud when I'm ready. To get started there, I create this Docker file. And what I'm doing in my Docker file is essentially setting up all of the environment items that I need. I'm telling it that I need ASP.NET 9. I need the .NET SDK version 9. I'm telling it what type of build to do for this application. And I'm telling it when an outside application attempts to reach my app, where does it find it? And I'm setting an entry point here for how outside applications will interact with my app. So I can create this Docker file, and it can get a lot more complex than this. This is a very simple version, but I can create this Docker file, and then I can build a Docker container, and I'll show you how to do that. I'm using this command. So I'll use Docker build. I'll pass in the -t flag, and then I'll give it my application name. So that's the name that it will show up in Docker. And then I'm going to tell it just to build the application that I'm currently in. I'm in Inventory API, which is the application folder, and I just want it to build whatever's here. So when I run this command, it will actually call out to Docker. It will compile my application, but then also pull in all the dependencies that's needed for my application to run independently in that container. So it's running all that now, and the container has been built. Now I'm going to switch over to Docker Desktop, which is an application that I can use to manage all my containers. And I'll show you that has now been built. My Inventory API application is here. It was just built. I have an image ID, so it's actually an image, which means that it's an isolated item that is running inside of Docker. And if I were to run this, I could interact with my Inventory API application as if it were running on a web server somewhere. And I can create multiple versions of it. I can duplicate this container. And let's say I duplicated it 3 times. I can run all 4 versions at once, and I can give them different entry points, and they can all do different specific things for me if I needed them to. But Docker is a very powerful tool for isolating your app, including all the dependencies that are needed, and then running them in a very streamlined and efficient way. Now that this container is built, I can also deploy it to Azure, to the cloud when needed, so that I can run it on the cloud as a container. That makes it very isolated, and it also makes it very efficient from a memory perspective, because I don't have to run a full Linux environment or a full Windows environment. I can just run it as a container, which has all the dependencies that it needs. So in this screencast, I configured an ASP.NET Core app for cloud deployment. I managed settings, secured connection strings, and containerized the application with Docker. These help me really ensure that the app runs securely, and containerization helps it run predictably when I get to a cloud environment. Applications are deployed using a combination of tools and workflows designed to make the process efficient and reliable. Understanding how to use these tools is essential for turning your code into a live, accessible product on Azure. In this video, we will identify the core tools and workflows for deploying applications to Azure. To begin, let's explore some of the key development tools and workflows for deploying applications to Azure, starting with Azure App Service. Recall that Azure App Service is a fully managed platform as a service, or PaaS, provided by Microsoft Azure for building, deploying, and scaling web apps and APIs. Azure App Service allows developers to focus on their app code while Azure manages the underlying infrastructure and scaling needs. For example, a financial services company might use Azure App Services to host its loan application system in the cloud, allowing customers to easily submit applications online. Azure App Services also ensures that the system benefits from automatic scaling to handle varying amounts of traffic and high availability for uninterrupted service. Once your app is hosted, it's crucial to manage resources efficiently, and this is where the tool Azure CLI comes in. The C, L, and I in the name stands for Command Line Interface. Azure CLI is a command line tool for managing Azure resources quickly and effectively. It simplifies tasks like creating, updating, and managing Azure resources, making it ideal for developers, system administrators, and DevOps professionals. For example, instead of navigating a web interface to create a database or configure a server, you can run a single command in the Azure CLI, saving time and simplifying your workflow. Another tool used for app deployment to Azure is GitHub Actions. GitHub Actions is a powerful automation platform integrated into GitHub that allows you to automate workflows for your software development projects. GitHub Actions can be tightly integrated with Azure to automate the entire process of building, testing, and deploying applications to Azure resources. For example, when using Azure-specific actions in your GitHub workflows, you can seamlessly deploy your code directly to Azure services like Azure App Service and Azure Functions. This allows you to focus on building features while ensuring your app remains up to date with minimal manual effort. Finally, let's explore the integrated terminal in VS Code. The integrated terminal in VS Code, or Visual Studio Code, is a built-in terminal that lets you write, test, and deploy your applications from a single workspace. The terminal is fully integrated into the VS Code editor, so you don't need to switch to a separate terminal window to run commands or scripts while working on your code. For example, you can manage your resources, test your application, and deploy it to Azure without ever leaving Visual Studio Code. The integrated terminal is a key feature in VS Code that streamlines the development process. It helps you stay within the same interface for coding, debugging, and command execution. In this video, you learned about the core tools and workflows for deploying applications to Azure. With the right tools, deployment becomes a process of precision and speed, taking your applications from concept to a live environment. Mastering these workflows helps prepare your projects for success on Azure. The Azure Command Line Interface, or CLI, is very powerful, and you can use it to deploy a simple app to Azure once you've developed it and created it. In this screencast, I'm going to explain how to use VS Code and Azure CLI to deploy a simple web app to Azure. The first thing I'm going to do is create a simple Blazor application using the Blazor Wasm template. I'll just call this Azure Web App for now. We'll run that and create this application, and then I'll open up that app in Visual Studio Code. Now we've got our application. We'll open up a terminal. We've got our application open, and I'm not going to make any changes to it. It's just the basic Wasm template. It has all the standard pages, the weather page, the counter page, and the home page. But all that will be fine to demonstrate how we can use our Azure Command Line Interface to push all this stuff to Azure. The first thing I need to do is log in. I'm going to use the AZ command, which is the Azure CLI, the Azure Command Line Interface that I've installed previously. And I'm going to use the login command to log into my account. When I run this command, it tells me that a web browser is open, and on a separate screen, I'm going to just log into my Azure account using my credentials. Once I've logged in, it's going to retrieve all my subscriptions from the Azure service. I've currently got this first one selected, so I'm not going to make any changes. I'll press enter, return on my keyboard, and then it will select that default one that I had ready to go. I've logged in to my Azure account, and I've selected the subscription that I want to use. We're ready to go, and we can actually start working with Azure using the command line. Now, the next thing I want to do is create a resource group for my application. I'm going to use a Azure command again, and I'm going to use AZ group create. This is my resource group. I'm going to give it a name. I'll call it test resource group. And I'm going to tell it the location that I want it to create this resource group in, and we'll just use East US as our location. The location of where the resource group is largely dependent on where you're located as a developer. You can do some research on which location is best. Some locations do not have all the services that you may need. So you want to do a little bit of research prior to setting up your resource group and other assets before you set a location. East US is safe. I know it has all the services that I need. Go ahead and create that resource group. And it comes back and tells me that it's provisioned, so it's succeeded. And it gives me some information about that resource group. The resource group is where we can put now all of our resources. Without a resource group, Azure won't know how to partition and set aside all the assets that we're going to need. I have to set up that resource group first. And the next thing I need to do is set up an app service plan. And the app service plan sets things like how fast the CPU should be, how much memory I want to allocate. And again, this will require some research on the developer's part before you set up an app service plan. You want to look at the different plans, what they offer, and how much they cost. There's a free version, which is what we're going to use here. You can use this free version to test. As you get into more production level applications, you'll want to increase your app service plan so that it can support more traffic and faster response times and the like. We'll start with this free version just to illustrate how it works. I'm going to create an app service using the AZ command again. And I'm going to use plan create this time. I've got AZ app service plan create. I'll give it a name. Again, for testing purposes, I'll call it test service plan. I have to tell which resource group it's a part of. So we'll use the resource group that we just created. And that was called test resource group. I'm going to tell it the plan that I want to use. In this case, the SKU is F1, which is the first tier free. Let me make sure I didn't put a space in between here. We've got three things going on here. I'm giving it the name of the service plan I want to create, the resource group that service plan is going to be in, which is the one we just created, and then the SKU, which is the level of service that I'm asking for when I create this plan, which is F1. Press enter on that. It's created the group for me, and it gives me a bunch of information about what's in that service plan. It's located in East US because that's where the resource group was, and it gives me all this other data that helps me know what's in my app service plan as I get ready to deploy my app. The final thing that I need to do now that I have my resource group and app service plan is to create the actual web app in Azure itself. This is just a basic web app that doesn't have any content, but that we can use to push our Blazor app into. This has all the settings and all the other items that Azure needs to be able to run our app on Azure's servers. I need to create that next, and I'll use an AZ command again. And this time we're going to create a web app. I'll give it a name. I'll use this name, test web app. I need to give it the resource group again because the resource group tells Azure where to put it, which is the one we created earlier. And the plan is test service plan. Okay, so again, we have three things going on here. We're going to create a web app called test web app. It has the resource group, which is the one we created earlier, test resource group, and then the there's some syntax here. Let me change this. I have to put this as the plan flag, and then the plan name is the test service plan, which is what we created earlier. So I'll go ahead and press enter on my keyboard, and it tells me that test web app already exists, so I need to change the name. It failed. Let me go ahead and try this again and just give it a different name. I'll call it 2. And that already exists. Let's try this one. I may not be able to get away with this because the names are too generic. Let's try something different here. Azure Web App. Let's try that as a unique name. What's happening is that someone else has created applications with these names, and it's not unique enough for Azure to be able to create a unique web app because these names actually appear in URLs on Azure's websites. They have to be pretty unique in order to be able to be created. Now, in a real world environment, you wouldn't be using such generic names. It's a lot easier to come up with your own unique name. In this case, because we were using test, there's other people that obviously had done the same thing and created those applications. But we found a unique name here. Now we're ready to go. Azure provides so much data back to you, every little detail about your application and how it's been created. It has things like IP addresses, location, number of workers available, and on. And you can go through all that data, save it so that you have it for future use, or you can use the JSON that's returned and store it for your own personal use later. Now I have all three things created. I've got my app service plan, I've got my resource group, and I've got my web app. And now I can actually push this application that I've created, my Blazor app, up to Azure and have it run in the cloud. Let's go ahead and use another command, AZ command. I'm going to use the web app command, and the up command tells Azure that I want to push the existing application. I'm in the Azure web app folder, and I'm going to push the local application to the application that I just created. I've got to remember what I called this. Let me go back up here and see what I called it. Azure Web App 595. And now I'm going to push this local app up to the Azure-based app. It's going through and telling me that it's already got the app exists, which is fine. We already knew that. And it's going to deploy the contents of this app up to that server. And it's telling me that it's updating the runtime version to .NET 6, and it's waiting for the runtime to propagate. So it's giving me all this information as it's attempting to deploy my app to the cloud. But it is working in the background, and the CLI is doing the job that we've asked it to do. By using this command line interface, you can get a lot of work done. You don't have to use the Azure portal to actually deploy your apps. By using the command line interface, you can write scripts and you can automate a lot of this process. So if you're deploying a lot of apps at once, or you want to automate builds or whatever, you can use the command line interface to more simply do the work that you need to do to deploy your applications to the cloud without having to use the graphical interface on the web. Now that our application has been deployed, and it's up to the test resource group, which we created earlier, and it's now ready to go and operate and run on the Azure platform. In this lab, we're going to deploy a basic HTML or console app to Azure using Azure CLI and VS Code. In step one, we're going to authenticate with the Azure CLI. I have the Azure command line interface, or CLI, installed, and I got that off of Azure's developer websites. And you can install that in the background. And then you can use this AZ command to interact with Azure, either from a PowerShell script, which I have here, a PS1 file, or I can run these commands right from the PowerShell terminal, which I have running down here. I'm going to do it in the PS1 file because it's a little easier to show. In step one, we're going to log in. We use the AZ login command. If we were to run this, it would pop up with a login page so that you can enter your credentials and log into your account. And then the second step is to run the AZ account show command, which will actually show me the accounts that I've logged into. That just verifies that I'm logged in properly. In step two, we're going to create Azure resources, again, right from the command line. We could do this on the Azure portal as well, but this is to demonstrate how we can do all this from the command line. So if you want to create a script that does this and then just run it, it's much easier to do it from the command line if you want to do everything all at once rather than clicking around the portal. The next step, we're going to create
a resource group. You can see here we use AZ group create. That's the command. In a real world scenario, you change my resource group to something more appropriate for your project. And then in the next blank as for AZ app service plan create. And so we're going to create an app service plan using this plan create command. And again, we have to give it the resource group name here. So this is the resource group we just set up. And then we would obviously give it a more appropriate name. My app service plan is the one we're using for this lab, but we would give it a more appropriate name there. And then the final command is to create the web app itself on the app service plan using the resource group we created in the first two lines. So we use the command AZ web app create, and that would allow us then to create our web application that we're going to use GitHub to push to. So these three commands, again, using the Azure Command Line Interface or CLI, will create a resource group for you, a plan and app service plan, and a web app. If you have these items created, for example, if you have a resource group already created, you can just use that resource group name when you're doing these other steps. Same thing with the service plan. You don't have to create those new. This just shows how to do that. In step 3, we're going to deploy the app to Azure. Assuming we're in a folder that has a web app that we want to push to Azure, I'm just going to put this step 3 line below this other code that we already have. We've got our web app created already. The next command is to use the AZ web app up. That's going to push the web app that we created up to Azure. So we've created the web app in this line called My Web App Demo, and then we're using that name to push that web app. Once we've created the application, then we can actually deploy it directly to Azure using the CLI. This final step 4 is just to document what we've done. I'm going to, again, paste this below our code. And these are just echo statements to remind us of what we've done here. Echo step 1 is that we signed in using the login command. Step 2, we created resources using the create command. And then in step 3, we deployed the app using the web app up command. So those are just statements that remind us of what we did in those previous steps, so that when we look at this script later, we have a good log of what we did.
Once you've deployed an app to cloud services like Azure, it's important to monitor them, and you can use open source tools like the command line interface to interact with your account. In this screencast, we're going to demonstrate how to monitor application performance and resource usage on Azure using open source tools. The command line interface is just one of those tools. I have Visual Studio Code open here with the terminal window, and I can interact with Azure through this interface, or I can open up a separate terminal or PowerShell window independently and do exactly the same commands. I have the command line interface tool installed in the background, and you can get that from azure.com or from Microsoft's developer portal. You can install the command line interface, and then you'll have it available to be able to run these commands. Before I can interact with my account on Azure, I have to log in. All Azure command line interface commands start with AZ. I'm going to start with AZ and then use the login command to log into my account. When I run this, it's going to open up a separate browser window, and that's off screen right now. And I'm just going to log into my Azure account from that browser window. Once I've logged in, the command line interface is going to retrieve all of the subscriptions that I have available to me on my Azure account. I have these various subscriptions, and I'm just going to keep the default one that I have. I'm going to press enter because I have no changes. And so now I've logged into my account, and I'm logged in with a specific subscription. Now I'm ready to interact with my Azure account. I'm going to just show some simple Azure command line interface commands that we can use. The first thing I'm going to do is look at how many accounts I actually have in my Azure subscription that I'm currently logged into. I can use AZ account list to show how many users are on my account. There's a couple here that gives me some information about each user. This will help me to know if someone that I didn't expect is on my account, or I can actually make changes to these accounts. And this gives me information that I might need for other Azure command line interface commands that I would use. Okay, let me clear the screen and we'll run another command called AZ group list. And this is going to list all the resource groups that I have available. Resource groups are buckets into which I can place other resources. And they just allow me to set a location where the servers are located, the location item there, Central US, whether it's provisioned. It gives me a bunch of data about these resource groups. And I have a number of resource groups in my account, and this will return a JSON package with information about each resource group that I have in my subscription that I'm currently logged into. Valuable information. If I need something specific like an ID for a resource group, I can use this command to get that ID and then use that in another command. And you can think about this in terms of automation. So if you need to get a specific ID for a resource group, and then use that in another command, that all can be automated in a script just by calling various command line interface commands as you're running through your automation. All right, let me clear the screen again, and then I'll run one more. I'm going to monitor the log analytics. So log analytics is a feature that developers can use to evaluate the performance of their workspaces, of their applications. So I'm going to just list what I have available, and I'm going to output this to a table, and I have to spell it right. Let me go back and finesse on that. Once I've run this command, it just gives in a table format. It's not well formatted on the screen because I made it so large, but it's in a table format, and it just gives me some information about the workspaces that I have, the location, and other information like that. So it just gives me some data. Again, this is a list command. So all I've asked it to do is just list this out. And that's also information that I can use to analyze the performance of how my sites are doing and how my applications are doing. All right, I'm going to clear the screen again. Now let's go a little bit deeper. Those are very basic commands that I use. Let's go a little bit deeper and look at some other things that we can do with the command line. So one of the things I want to do is be able to monitor the performance of specific apps that I'm running on Azure. So I've got some commands here that I've already put together. There's just a lot of information that these commands need. It needs the subscription ID and the resource group ID and the web app name. So instead of typing all that out, I've already pre-written them, and I'm going to paste that in here, and we're going to look at some metrics. The command is AZ Monitor metrics, and then the definitions for the specific subscription, resource group, and this app called Microsoft Dev Web App. So when I run this, it will go out to Azure and pull back information specifically about this web application. And it gives me a bunch of information. There's a health check status here for web apps and functions apps. It's just listing out all the things that I can evaluate for this app. And I can use this information to determine whether the app is functioning well or poorly. And then I can make changes as needed to improve the app performance if something doesn't look right. So this type of information is very valuable for when I'm trying to assess how my application is doing. Now you can also use the Azure portal to get information about your app performance. By using these command line interface commands, you can retrieve all the information in JSON format, and then you can have tools evaluate it. So you can throw it into an AI tool like Microsoft Copilot or ChatGPT, and you can have them evaluate and ask those tools whether there's something that doesn't look right. Or you can run your own calculations and do metrics over time and create charts and do a own analysis by using the data that's coming back, rather than having to use the portal and just getting snapshots in time. This last command gave us a lot of high-level data about our application. But I can actually drill in even further by using a slightly different command with flags at the end of the command to drill down on very specific types of data. So for example, I can use this list command. The previous one was list definitions, which just gave me that high level data. This is AZ Monitor metrics list, and I'm using the metric flag at the end, and I'm going to ask specifically for the CPU time. So I can measure the CPU time for this specific app over time. And Azure CLI will return a bunch of data that will tell me how the CPU is performing for this application on my instance. It gives me a lot of information here, and how much the CPU was being processed during these different timestamps. You can see it's a very specific type of request. I would never be able to use this very accurately just using it visually, but I can throw this into a tool and have that tool analyze it over time. This app is not running under any strain at all. The total for most of these seconds is a 0 CPU time. That's because it's just a sample app and no one's hitting it. But you can also see that I can use this tool to get accurate data about how an app is performing over time and how much CPU strain it's taking. If I notice, for example, that over a period of many minutes, the app is using 100% of the CPU, it either may mean that I've got a bug in my application or that the app is being used pretty heavily, and then I may need to increase my CPU size and change my app service plan because of the way that the app is being used. But this data allows me to see that and make decisions based on what I'm getting back from Azure. Finally, I can use the CLI to actually review logs. So as apps are running, Azure is creating log files that display errors or other information about the app as it's being run. I can use the CLI to get information about those logs. Here I'm using Azure Monitor Log Analytics, which is the tool that pulls from the logs, giving a specific query. I want to query this workspace with a specific ID. And I want to use Azure Diagnostics as the key value pair for that query. And I'm only going to take 10 records at the beginning because I don't want to be inundated with too many records on my first run here. I'll go ahead and run that. And the command line interface will give me whatever results are returned for that workspace. In this instance, I don't have any logs created because I created a test app. But this illustrates that I will get an array back. Those two brackets indicate an array. I will get an array back from the command that has information about the app from the app logs themselves rather than from real-time data that it's collecting. So log data is very good for analyzing historical information about your app. And you can use the command line interface to retrieve a JSON object that creates data about those logs. Then you can compare the historical data with the current data if that's important, and then you can do some analysis on that to see how your app is running. So in the screencast, I demonstrated how to use the command line interface to retrieve some very important information. I've obviously just scratched the surface. There's many more things you can do in terms of using the CLI to monitor application performance and resource usage. In addition to using the Azure portal, the command line interface gives you a lot of options and a lot of power, particularly if you want to automate or analyze the data that you're getting out of the Azure services.
Application management doesn't stop after applications are deployed. They need continuous monitoring to ensure performance and reliability. Without the right tools, small issues like slow response times or high resource usage can escalate into major failures, impacting users and business operations. In this video, we'll explain how to monitor application performance and resource usage using Azure tools. To begin, let's explore the main Azure tool for monitoring performance and resource usage, Azure Monitor. Azure Monitor is a cloud-based service that collects, analyzes, and visualizes transmitted data from applications and infrastructure to enhance performance and reliability. It provides insights through metrics, logs, alerts, and dashboards, helping organizations detect and resolve issues proactively. For example, imagine a company's website suddenly slowing down. Developers can check Azure Monitor and notice CPU usage has spiked. With this insight, they can quickly scale up resources, preventing a crash and keeping the site running. Now that we've explored what Azure Monitor is and how it's useful for monitoring application performance, let's explore some of its features, starting with Application Insights. Application Insights is a feature of Azure Monitor that helps developers track application performance, detect anomalies, and diagnose issues in real time. It provides in-depth analytics and visualizations, such as performance metrics, dependency tracking, and failure diagnostics, enabling teams to identify bottlenecks, optimize resource usage, and enhance overall application reliability and user experience. For example, imagine that a retail company launches a new checkout system, but customers begin reporting delays when placing orders. Using application insights, developers analyze transaction logs and trace the issue to a slow API request. By optimizing the query, they instantly improve checkout speed, enhancing the shopping experience. Monitoring is only a part of the equation. Applications must also adapt dynamically to changes in workload, which is where autoscaling comes in. Autoscaling is the process of automatically adjusting computing resources based on demand to ensure optimal performance and financial cost efficiency. In Azure, autoscaling is implemented using Azure Monitor Autoscale, which monitors key performance indicators like CPU usage, memory utilization, or request rates, and scales resources up or down to maintain performance and cost efficiency. For example, imagine a live stream concert attracting millions of viewers. As the audience grows, the platform's traffic spikes dramatically. Instead of servers struggling to keep up, Azure Monitor Autoscale increases the number of instances to handle the demand. Once the concert ends and traffic decreases, the system scales down to reduce costs. In this video, you learned how to monitor application performance and resource usage on Azure using tools. With tools like Azure Monitor, Application Insights, and Azure Monitor Autoscale, developers can detect, analyze, and resolve performance issues before they affect users, keeping your applications reactive and enabling a great user experience. Unauthorized access to applications exposes sensitive data, disrupts operations, and leads to compliance violations. A strong identity management strategy ensures that only the right users can access the right resources, reducing security risks. In this video, we'll explain how to secure applications using Azure Identity Management tools. To begin, let's explore some of Azure's tools and techniques for managing identities, starting with Azure Active Directory, or AAD. This is also called Microsoft Entra ID. Azure Active Directory is a cloud-based identity and access management service that helps organizations securely manage user authentication and access to resources. AAD enhances security by managing user identities, enforcing authentication policies, and protecting against unauthorized access. For example, a company could use AAD to enable employees to log in once with their work credentials and access multiple business applications without needing separate usernames and passwords. It simplifies authentication while maintaining security. AAD secures authentication, but alone, it might not be enough to prevent unauthorized access. To add another layer of security, you can implement multi-factor authentication, or MFA. Multi-factor authentication is a security feature that requires users to verify their identity using multiple authentication methods before accessing an application. This adds an extra layer of protection against unauthorized access by making it harder for attackers to compromise accounts. In Azure, MFA is offered through Azure Active Directory and allows you to enforce additional security by requiring a second form of verification when users sign in. This ensures that even if someone steals the employee's password, they cannot access the account without the second authentication factor. For example, when an employee logs into a company's cloud portal using MFA through the Azure Active Directory, they first enter their username and password. After the initial login, the employee is prompted to verify their identity by entering a one-time code that is sent to their mobile phone via a text message. Access is only granted after both the login and the one-time code are correctly provided. Multi-factor authentication controls who can log in, but role-based access control defines what users can do once they're inside of an application. Role-based access control, or RBAC, is a security model where access to resources is granted based on a user's role within an organization. Users are assigned roles, and each role has a specific permission that defines what actions can be performed on the resource. Azure provides built-in roles like owner, contributor, and reader, and custom roles can also be created to define specific permissions for different users or groups within the Azure portal.
For example, in an Azure environment, an owner role has full control over resources. A contributor role can create and manage resources, but not assign roles, and a reader role can only view them. This ensures that users have appropriate access levels, preventing unauthorized modifications while allowing visibility where needed. In this video, you learned how to secure applications using Azure Identity Management tools. Identity management is a crucial layer of security that ensures users access only what they need. By leveraging AAD, RBAC, and MFA, organizations reduce risks, strengthen security, and prepare for more advanced cloud security strategies. Once you've deployed an app to the cloud, it's important to make sure that you have the right security measures applied so that you can keep your app and its data safe. In this screencast, we're going to demonstrate how to secure applications using Azure Identity Management tools. I'm mainly going to work out of the command line, but we're going to also pop into the Azure portal to take a look at a couple of other security features we can add. I've got an app deployed to Azure. I'm going to use the command line to apply Active Directory or AAD security to that application. Active Directory is actually now Entra ID on Azure. So I may go back and forth between the terms, but we're going to be using the Entra ID services on Azure to secure the application. So the first thing I want to do is register the app with Active Directory, and I'm going to use the AZ command, which is the Azure CLI, the Azure Command Line Interface. And the first thing I'm going to do is create an Azure AD directory or an Entra ID directory. I'm going to call that directory Secure Web App, and I'm going to give it the URI to my website. This is the URI that I have published to Azure, and I'm going to pass in that URI as I create the command. All we're doing at this point is setting up the app in Azure Active Directory, and then we can apply permissions later. Go ahead and run that command, and Azure returns a JSON package letting me know that the Active Directory was either updated or created. In this command, I use the create option. If that directory is already created, then it will just update it with the parameters that I passed in. Now we have Active Directory applied to that application. And the second step that I want to do to secure my application is to enable multi-factor authentication. This goes beyond passwords. It's the services that you'll see like when you're sent a code to get access to that website. It's a similar type of system where you can use two different ways of authenticating a user to make sure that your application is safe. I'm going to switch over to the Azure portal. I'm going to go into the Azure Entra ID service and look at the multi-factor authentication options. I just did a quick search at the top level for Microsoft Entra ID. Yeah, it gives me the default directory, which is the one that I'm working in. And this is on my tenant. It's applicable to all the services that use Entra ID. I'm going to go into the security option. Under security, under the manage option, there is multi-factor authentication. And here's where I can set multi-factor authentication options for my service. I have to actually pay for this. This is not a free service to use MFA, but I get a trial if I wanted to, and then I can play around with different multi-factor authentication options. If you have a website or an application that has a lot of sensitive data, using multi-factor authentication can ensure that your data is safe and generally is a good idea for modern websites. All right, the last thing I'm going to do is go back to Azure Active Directory, and I'm going to apply role-based access control, or RBAC, to my application and a very specific user on that application. I'm going to use the command line interface again, and I'm going to assign a reader role to a user in my organization. What I have here now is the AZ role assignment create. That's the command that I'm sending. And this is creating a role assignment for a specific assignee or a user. I'm passing in the ID here, which is a long number with some dashes in the middle. That assignee is identifying a user that I have in my system, and I can look that up either on the Azure portal or using the command line. I'm going to assign it the role of reader, and I'm just scoping that assignment to my app. It's my MSFT-dev-web app. That's the only application that will get this assignment. I can scope it way down. I have to give it the subscription ID and then the specific resource group that the application is in, which is MSFT-dev. And then I'm going to assign that role to that user for this application. I'll go ahead and run that command. And then it comes back with a bunch of information letting me know that user has been assigned that role on that application. And now that user is locked down, they can only read the application. They can't go in and make any changes or modify any settings. These are just 3 quick ways that you can use Azure tools to lock down your website to make it more secure. By using Azure command line interface tools, you can automate a lot of this. If you have a bunch of users that you need to assign permissions to, you can automate that, create a script, and use the command line interface to quickly assign roles in the intra ID system.
Every piece of data you handle contains value, often more than you realize. Safeguarding that data, whether it's stored or in motion, and protecting the network it travels through is not just a technical requirement, but a foundation of trust and security. In this video, we will identify best practices for encrypting data and securing networks. To begin, let's explore some key security practices for back-end systems, starting with encrypting data at rest. Encryption at rest is the process of encoding data while it's stored on a disk, database, or other storage medium to protect it from unauthorized access. This ensures that even if someone gains physical access to the storage, they cannot read the data without the proper decryption key. It is commonly used in cloud storage, databases, and file systems to enhance data security. Now let's examine 2 key practices for encrypting data at rest. One practice of encrypting data at rest is using the trusted standard, referred to as the Advanced Encryption Standard, which uses a 256-bit key, or AES 256 encryption. This standard is commonly employed in applications like encrypted databases, secure cloud storage, and VPNs, which all need to protect sensitive information from unauthorized access. For examples, hospitals use AES 256 to encrypt patient records, ensuring sensitive information is protected even if devices are lost or stolen. You must also ensure that your encryption keys are secure, so another practice is to rotate encryption keys regularly. For instance, a retail company rotates encryption keys every 6 months to prevent misuse. Once stored data is secure with the encryption at rest, the next step is to protect data traveling across networks, which is where encrypting data in transit comes in. Encryption in transit secures data by encrypting it while it moves between systems, ensuring it cannot be intercepted by unauthorized users. For example, when you enter login credentials on a banking website, Transport Layer Security, or TLS, a type of encryption in transit, ensures your data is securely transmitted from your device to the bank's servers. Now let's examine some key practices for implementing encryption in transit. Using TLS version 1.3 is a good practice for encrypting data in transit. It provides strong encryption and secure communication, protecting data from interception and tampering during transmission. TLS 1.3 encrypts communication like login credentials, offering stronger security and faster performance than older versions. To further enhance security, practice enforcing HTTPS-only connections. These connections are cookies that can only be accessed by the server and not by JavaScript running in the browser, enhancing security by making data less vulnerable to malicious scripts. For example, an e-commerce site that restricts traffic to HTTPS-only connections ensures customer details like payment information are transmitted securely. After you've secured your data, controlling access to your network is vital to building a robust security strategy, which is where network security groups, or NSGs, come in. Network security groups are a set of rules used in cloud environments like Microsoft's Azure to control inbound and outbound network traffic to resources.
They act as virtual firewalls to enforce security policies by allowing or blocking traffic based on factors such as IP address, port, and protocol. One best practice when using network security groups is to create explicit rules to define who or what can access your network to reduce accidental exposure. For example, an organization might define access rules to allow only certain IP addresses or applications to connect to their database. Once explicit rules are created, they must be audited regularly. You minimize potential security risks by reviewing and removing outdated or unnecessary permissions on a regular basis. In this video, you learned about best practices for encrypting data and securing networks. By securing data at rest, encrypting it in transit, and controlling network access, you create a shield that safeguards both your systems and the people who rely on them. These practices are essential for building a resilient and trustworthy foundation in any organization. An online retailer hasn't properly secured its database, exposing thousands of credit card numbers. The result? Fines, lawsuits, and lost trust. Compliance helps prevent these risks by enforcing security best practices. In this video, we'll explain how to ensure compliance with regulations and perform security audits using Azure tools. To begin, let's explore some compliance and auditing steps, starting with Azure Security Center. Azure Security Center is a cloud security solution that helps protect your cloud and online premises systems by providing security posture management and advanced threat protection. It offers real-time threat detection, compliance monitoring, and AI-driven security recommendations to enhance cloud security. For example, if a company stores customer data without encryption, Azure Security Center flags the issue and recommends enabling encryption to protect sensitive information. It continually enforces security policies and provides guidance to fix vulnerabilities before they become major risks. Azure Security Center focuses on security threats. However, businesses also need to ensure they meet industry regulations, which is where Compliance Manager helps out. Compliance Manager is a Microsoft tool that helps organizations assess, manage, and improve compliance with industry standards, regulations, and company policies. It provides pre-built assessment templates, automated risk tracking, and detailed compliance reports to help businesses comply with laws such as GDPR in Europe and HIPAA in the United States. For example, a hospital using Azure to store patient records can check if security settings align with HIPAA, which is a U.S. law that protects sensitive patient health information from being disclosed without consent. Multi-factor authentication, or MFA, helps protect patient records by requiring multiple forms of verification. If MFA isn't enabled, Compliance Manager will likely highlight the issue and suggest enabling it to enhance security. Even with compliance tracking in place, misconfigurations can occur, which is why security audits are needed. Security audits are systematic evaluations of an organization's IT infrastructure, policies, and procedures to assess security risks and ensure compliance with industry standards. These audits review access controls, data protection, and system configurations to identify vulnerabilities and ensure security best practices. In Azure, security audits are conducted using tools like Microsoft Defender for Cloud, which assesses security risks and provides recommendations, and Compliance Manager, which helps track regulatory compliance. For example, a healthcare company using Azure may conduct a security audit with Microsoft Defender for Cloud to detect vulnerabilities in its cloud storage and virtual machines. Compliance Manager can then be used to assess whether the company's data handling meets regulations. The security audit helps the company identify risks such as improper access controls and implement security measures to protect patient data. In this video, you learned how to ensure compliance with regulations and perform security audits. Using tools like Azure Security Center and Compliance Manager, businesses can manage security and compliance, reducing risks and ensuring data protection. Regular audits and best practices also help safeguard the organization and customers, building trust and mitigating threats. Once you've deployed an app to a cloud service like Azure, you can use tools to monitor and update compliance and security and do security audits on that service. In this screencast, I'm going to explain how to ensure compliance with regulations and perform security audits. I have Visual Studio Code open with a terminal window. I could use a general terminal or PowerShell window if I wanted to. I'm just going to work out of Visual Studio Code. I have a command prompt and I've logged into the Azure service using the Azure command line interface, the CLI, which I've installed, and I've logged in using AZ login. What I'm able to do now is run security tests and audits against my Azure subscription. These tools will give me an assessment of how my applications evaluated during certain security measures. The first thing I'm going to do is just get a list of items that need to be assessed. And I can use this command AZ security assessment list. This will just provide me with a list of the things that I can evaluate. I want to run this command. And it will come back with a list of items in my Azure subscription and tell me what the status is. I have some resources that it's come back with, the subscription it's part of, and what the status is. It tells me, for example, in this one that we're looking at, that the situation is unhealthy. I can take a look at what the assessment is evaluating. Microsoft Defender for servers should be enabled. It's telling me what the problem is and why it's unhealthy. And it's giving me some feedback on how I can improve the security of this specific resource, of this specific asset. And I've got pages of this that's returned and I can evaluate each one. The assessment is coming back in a JSON format, so I can easily consume that JSON, put it in a tool, create a dashboard, or whatever else I need to do, even run automation tools to better improve the security of my applications and provide some information to other people on my team if I needed to about the security of the different assets in my subscription. The other thing I can do is create a list of the tasks that need to be done. I'm going to also have this returned in JSON. I'll go back to my command line. I'll go ahead and clear out the terminal so we can better see this. Now I'm going to actually ask Azure to provide me with a task list. And again, this will be in JSON. It'll be in a format that will be easy to consume in a tool and then provide a easy to read list. But I'm going to have it returned in JSON for this screencast. We'll go ahead and pull that out. It's giving me some information on some of the assets that I have in my subscription, and I can go through and evaluate what's happening here. In this task list, it's for this resource that's on screen now. It says that this application should only be accessible over HTTPS. Under policy name here is telling me that this particular resource doesn't have HTTPS only enabled. And so if I wanted to make this more secure, I should enable that setting on this web application. It also gives me a severity rating for this particular task. And in this case, this is set to medium. This is really good information if I want to assess the status of my applications, but also have a really easy to use list that I could apply and use to update the security of my applications. Another thing that Azure will enable me to do is to see how well my applications comply to regulations. For example, this uses Compliance Manager, and it helps me track frameworks like HIPAA, GDPR, ISO, and all the rest, so that I can see how my applications are assessed against those different regulations. And this can be very helpful, particularly if you're working in an environment that is regulated. I'm not going to run this command specifically because I don't have any applications that are a part of a subscription where this would provide any meaningful feedback. But let's go through this command. It's the AZ security command that we're looking at here. And I'm passing in this flag, regulatory compliance list standards. And it's just going to provide a list of any assets you'd have in your subscription that could apply to regulatory compliance, and it will tell you whether those apps are conformant or not and where they're out of compliance. This is a really nice list that you can use to make sure that the apps that you're working with are complying to those various frameworks that I described earlier. Finally, I can use the AZ tool to improve the security of my databases. Let's suppose I did that security audit and I saw in the list that one of my databases needs to be updated so that it uses transparent data encryption. I can run this command, AZ SQL DB update. That command will allow me to actually update my database. I don't have any specific database that I'm going to apply this to, but I give it my database name, which I can get from the Azure portal or from another command line that I run to provide me with all my databases. I give it my resource group name. Here it's just my group. And then I give it my specific SQL server name. So my server would be my server, but in a real world environment, you give it the database server that you want it to apply to. I would pass in this flag, transparent data encryption is the flag, and I'm setting it to enabled. Just simply using the command line, I can update the security of my SQL Server database and turn on transparent data encryption based on the audit that I had performed earlier in the screencast. I could look through that audit list, find out that this database doesn't have this security feature applied, and then use the command line to apply that security. But using these Azure tools and the command line tools alone, without having to go into the portal, you can not only get an audit and perform an audit of all the assets in your subscription, but you can use Azure tools, command line tools, to then fix those audit issues. And you can use automation to do this. You can have a script automatically each day run through and assess the items in your subscription, and then also use those automation tools to update any resources that need to be more secure. Once your app is on a cloud service, it's a good idea to perform regular assessments and do regular security audits, and then make sure that all of your assets are as secure as they possibly can be. Understanding how to deploy, manage, and secure applications in Azure is essential for modern cloud-based development. It ensures that applications are scalable, efficient, and protected in a dynamic cloud environment. We began by exploring Azure Cloud Services, examining their core features and the benefits they brought to application deployment. You discovered how Azure enhanced scalability, strengthened security, and optimized efficiency for cloud-based solutions. Next, we broke down the key steps for preparing applications for deployment to Azure, including configuration setup, compatibility assessments, and performance optimizations to facilitate a smooth transition to the cloud. Then we explored various deployment strategies, essential tools and best practices for deploying web applications on Azure to ensure efficient and seamless application launches. After that, we examined strategies for managing and securing applications in Azure, emphasizing monitoring techniques, access control measures, and compliance practices to ensure stability and protect cloud environments. Finally, we reviewed best practices for securing applications on Azure, identified common security challenges, and explored effective techniques to safeguard applications against potential threats. Effectively deploying, managing, and securing applications in Azure is essential for maintaining reliable and scalable cloud-based solutions. Applying these strategies will enhance performance, strengthen security, and ensure long-term success in cloud development. Efficient software development relies on automation, consistency, and streamlined workflows. In this module, setting up CI/CD pipelines with GitHub Actions and Azure DevOps, you'll explore how CI/CD principles enhance back-end development, ensuring smooth integration and deployment. We will introduce the core principles of continuous integration and continuous deployment, CI/CD, exploring how they streamline back-end development by automating testing, integration, and deployment processes.
Next, we will examine the role of CI/CD pipelines in automating deployment workflows and breaking down key components and best practices to ensure efficient, reliable, and scalable application releases. Then we will explore how to set up GitHub Actions for CI/CD and learn how to create workflows that automate code integration, testing, and deployment directly within GitHub's ecosystem. After that, we will dive into Azure DevOps, discovering how it integrates with CI/CD pipelines to automate development workflows, manage releases, and enhance collaboration across teams. Finally, we will focus on monitoring and maintaining CI/CD pipelines, identifying effective techniques for tracking performance, troubleshooting issues, and ensuring seamless, continuous software delivery. By the end of this module, you'll be equipped with the skills to automate workflows, optimize deployments, and maintain reliable pipelines for continuous software delivery. Let's get started. Delivering reliable software updates quickly is a challenge every company is up against. The principles of continuous integration, or CI, and continuous deployment, or CD, provide a solution by automating integration, testing, and deployment. These practices set the standard for modern software delivery and enable backend systems to handle challenges efficiently and error-free. In this video, we will define CI/CD benefits and how they enhance software delivery for backend systems. Let's start by defining continuous integration to understand how it transforms software workflows. Continuous integration is the practice of automatically merging code into source control tools like GitHub and testing changes frequently to ensure stability and avoid integration issues. This process helps identify conflicts or bugs early, minimizing integration headaches when multiple developers collaborate. While CI addresses integrating new or updated code into an existing code base, continuous deployment focuses on what happens after testing and streamlines the process of delivering updates to users. Continuous deployment is a software development practice where code changes that pass automated tests are automatically deployed to production without manual intervention. This ensures that software updates are delivered quickly and reliably, allowing for faster feature releases and bug fixes. Now that we've defined CI/CD, let's explore some key benefits it brings to software delivery. CI/CD allows teams to improve update speed by automating tasks like code testing and integration. For example, imagine a telemedicine company needing to roll out features like real-time chat or appointment scheduling. With CI/CD, these updates can be delivered in hours instead of weeks, helping them deploy these new features faster. The CI/CD process improves quality by integrating and delivering new code much more frequently than without this process. CI/CD can reduce bugs by enabling development teams to catch issues early using automated testing and continuous feedback. For example, developers can rely on automated pipelines to ensure new or updated code from multiple developers is stable and reliable before it reaches users, resulting in fewer disruptions and improved software quality. CI/CD also promotes better collaboration by simplifying integration processes and minimizing conflicts between developers. When teams work on different parts of the same project, CI/CD ensures their changes align seamlessly, allowing them to focus on innovation rather than troubleshooting. A final benefit of CI/CD pipelines is that they can handle errors using rollback mechanisms. When a deployment fails, the system can automatically revert to the last stable version, reducing the risk of outages and minimizing disruptions. This approach is key to ensuring reliability, especially in high availability systems where downtime can have a significant impact. In this video, you learned about CI/CD principles and how they enhance software delivery for backend systems. By adopting these principles, you're taking a significant step towards creating faster, more reliable backend workflows. With CI/CD, you'll enable your systems to meet the speed and reliability today's users expect. In the software development industry, speed and reliability are essential. To meet these needs, we use CI/CD pipelines, which help ensure that we can effectively build, test, and deploy software. In this video, we will identify the essential components required to build continuous integration and continuous deployment pipelines. To begin, let's explore the essential pipeline components of continuous integration, or CI, and continuous deployment, or CD, starting with source control. Source control is a system that tracks and manages changes to code, documents, or other files over time. It allows multiple developers to collaborate on a project, maintain a history of changes, and revert to previous versions if needed. This keeps the code base consistent, organized, and free from versioning conflicts. For example, a development team uses a source control tool like GitHub to track changes to their application code. This allows multiple developers to collaborate without overwriting each other's work. If a bug is introduced in a recent update, users can quickly restore functionality by reverting to a previous version using source control. Another essential component of the CI and CD pipeline is build automation, which ensures that updated code is ready for the next stages. Build automation is the process of using scripts or tools to automatically compile, package, and deploy software applications without manual intervention. It streamlines repetitive tasks such as fetching dependencies, running tests, and generating executable files, improving efficiency and consistency in the development workflow. For example, a software development team can use build automation to compile their application code, run tests, and generate deployment-ready files whenever changes are pushed to the repository. This ensures that every update is consistently built and tested, reducing manual errors and speeding up the development process. Once the build is complete, the next essential component of the CI and CD pipeline is testing automation, which ensures the code performs as expected. Testing automation involves using specialized software tools to execute tests, compare actual outcomes with expected results, and report findings without human intervention. It helps ensure software quality by running repetitive and complex test cases efficiently across different environments. For example, a software development team can add a new login feature to their app and automate tests to ensure it functions correctly across various scenarios. This will save development time and provide immediate feedback on code quality. A final essential component in the CI and CD pipelines is deployment automation, which takes your code from development to production without manual intervention. Deployment automation is the process of automatically releasing and deploying applications to various environments, such as development, testing, and production, without manual intervention. It ensures consistency, reduces human error, and speeds up the deployment process. Tools like Azure DevOps help automate deployment by handling tasks such as code compilation, testing, packaging, and infrastructure provisioning. For example, software companies can use deployment automation to push their updates to cloud-based applications without manual intervention, ensuring faster and error-free releases. By integrating deployment automation into their CI/CD pipeline, they can automatically deploy new features and bug fixes to production as soon as they're past testing. In this video, you learned about the essential components required to build CI and CD pipelines. Gaining expertise in these components equips developers to innovate with confidence, making software delivery faster and more reliable.
Using continuous integration and continuous deployment workflows, or CI/CD workflows, can really help make sure that your code is kept secure, that you're creating regular versions of all the code that you're writing, and can help you integrate code from various developers, as well as distribute and deploy your code to your users as it changes. So in this screencast, I'm going to explain how to configure and run a basic CI/CD pipeline workflow. I have a simple console application here. We're going to add the code for this application to a local Git repository, and then push that code to a GitHub repository where we can see how the continuous deployment and integration works. The first thing I'm going to do is create a Git repository for this application. I'm going to initialize it using this Git command. I'm using the Git command line interface, which I've installed separately, and you can install that in Visual Studio Code, or you can use a regular terminal window or PowerShell on Windows to run these commands. There's also a GitHub command line interface. It's the GH command, and you can install that toolkit as well. So once you've installed those, then you can run the git and the gh commands from any terminal window. So let's initialize the repository. It's initialized that repository for me. Now we have a Git repository locally, and now we can add the files that are in this project to that repository using the git add dot. The dot just tells Git that I want to add everything in this project to the repository. So I'll go ahead and add those files, and the fact that it didn't return anything means that it worked. And now I'm going to commit those files to the repository. Using the commit command actually puts the files into the repository. Add just stages them. It tells Git that these are the files that I want to commit. I've added them, and now I'm going to commit them. I have to give it a message, so I'm just going to say this is my initial commit. Those files have been added to my local Git repository, and now I can push those to GitHub. And for that, I'm going to use the gh command. The first thing I'm going to do in this command is create a repo. So I'm going to use the git gh repo create. I'll call this hello CI/CD. That's the name of the GitHub repository that I'll create on GitHub. Create this as a private repository. The other keyword is public if you want to make that available to anyone on the internet. And then I'm going to tell it that the source is everything in my local Git repository. I'm using the dot here. Is just this project. I'm telling it to push everything that's in this project. The final switch we need to add is push, and that's telling the GitHub command line tool to push everything to that remote repository when I run this command. All right, so we're doing three things. We're specifying the name, the source, all the files that we want to push, and then the command, which is push. Go ahead and run that. And it tells me that the repository was created. Hello, CI/CD. There's 30 objects. It counted the objects, it compressed them, it wrote the objects, and then it pushed them to the repository on GitHub. So now they're available on my GitHub Cloud account, and I can view them. I'm going to switch over to my browser and go to my GitHub account. There's the repository I created, hello CI/CD. All the files that were in my local folder on my computer have now been pushed to the GitHub account. Now I can continue to interact with this and make sure that all my files are stored in every version that I create. I can push up to GitHub and they'll be securely stored there. Now the next thing we want to do is to create this CI/CD pipeline. So let's go back to our project. I've created a .github folder, and underneath that folder there's a workflows folder. So there's .github/workflows, and that format needs to be very specific for working with Azure workflows. And then I created this file called a YAML file, a YMI file, and it's just a very specifically formatted file, and it's called .net.yaml, which is my workflow file. Let's get into that file, and this is where we create our syntax for our continuous integration and deployment. We're not going to go through every line of this file, but it's some of the key items that are in it. There's key value pairs. There's a key followed by a colon, and then the value that's followed from that. The first thing we do is just give it a name, .NET build and deploy. Then we give it a trigger. We're going to say, when do we want this workflow to run? We're going to describe that. And we want it to run on every push. So every time we push to the branch master, this workflow will run. And anytime anything is pulled from master, it will also run. So we can give it two different events to trigger on. We have a push and a pull event, and it's only going to happen on the master branch in GitHub. Anytime those events occur, then this workflow will run. There's a jobs category, and then there's a specific tasks that's run. In this case, it's build. What we're going to specify that the job that we want to run is on any push or pull. We want this application to be built. We tell it what server we want it to be built on, and then we give it our steps. We give it independent steps. The syntax here is very specific, and you can do independent research to figure out what types of steps that you want to run, in this case, build action. And then these individual steps will be run. There's a name and then a specific command. The first thing we're doing here is restoring dependencies, and then we run the command .NET restore. The next thing we do is build, and then we run the command .NET build. We can run each of these steps after each of these events occur. Then we'll have our application ready to go. And when you're pushing your code up to GitHub and these actions run, your application will be ready for the user, because not only have we built it, but we've tested it, and then we've published our application, and then it's ready to go. So you can run any number of commands. You can have, for example, a website. You can do a number of things on a website and have that publish directly to your public-facing URL. Then your website's always ready to go just by checking in your code to GitHub. So let's make a change to this and see how this works. I'm going to make a change to my file. Just a simple change to the string that's written to the console. Now we've made that change, and the files are automatically saved in Visual Studio Code, so that file has now been saved. And now I need to go ahead and add the changes to my local repository, so I'm going to use the git command again. I've added it, and now I'm going to commit it as I did before. Give it a message. Now let's just be more specific. Changed program.cs. So now we've changed that. So now we're committing it to our local repository, or Git repository. You can see one file's changed. Now we're ready to push it up to GitHub. So I use the git command, and I'll use git push. Now I'm using git here because I'm telling my local Git repository to push any changes to the GitHub repository. So I'm going to use git push, and pushed it actually to github.com at my account, hello cicd.git. Now I'm going to quickly switch over to my project, and we're going to go into the Actions tab. I have the .NET build and deploy, which is the name of that YAML file. That workflow is now running. So it's in progress. It's running right now because I just pushed that change. And so now it's going to run through each of those actions that I specified in that YAML file. This is occurring in real time. The build has occurred. So let's go back to Actions, and it's finished. We're getting that green check mark. All the actions in that YAML file have been performed because I simply pushed my changes to GitHub. And here's all the commands that are run. And these are just the ones that we looked at on my local computer. This is how GitHub workflow, CI/CD workflows work. Just simply by pushing that file to GitHub, we were able to get that change pushed, and then the build commands ran from the .NET.YAML. This is a very simple example of how CI/CD can help you continually integrate and deploy changes to your code. There's a lot more commands that you can include, and it gives you a very powerful way to make sure that your code not only is secure, but that your users are always getting the latest and the greatest of the code that you're creating.
Automating tasks is essential to delivering software efficiently and reliably. GitHub Actions simplifies this process, allowing developers to create workflows that handle everything from testing to deployment with ease. In this video, we will describe the role and core components of GitHub Actions for automating CI/CD pipelines. Recall that GitHub Actions is a continuous integration and continuous delivery, or CI/CD platform, that allows developers to automate their build, test, and deployment pipeline. It enables the creation of automated workflows that integrate with GitHub events to streamline software development processes. For example, a developer can use GitHub Actions to automatically run tests and deploy a web application whenever new code is pushed to the main branch. This ensures that the application remains stable and up to date without requiring manual intervention. Now that we've explored GitHub Actions, let's examine some of its core components, starting with workflows and how they help automate processes in the CI/CD pipeline. In the context of GitHub Actions, workflows are automated processes defined in YAML files that specify how and when to run CI/CD tasks. YAML, which stands for Yet Another Markup Language, is a structured and human-readable format that makes it easy to define and organize workflows. Workflows are beneficial because they automate repetitive tasks such as building, testing, and deploying code, improving efficiency
and reducing manual effort. Workflows also ensure consistency and reliability by executing predefined steps in response to events like code pushes or pull requests, streamlining the software development lifecycle. For example, a workflow could be set up to test and deploy your application whenever new code is pushed to your repository. We need to explore another component of GitHub Actions workflows, jobs, which helps automate tasks in a workflow. A job is a set of steps in a workflow that are executed on the same server that runs your workflow. Jobs are important because they allow tasks to be organized and run in parallel or sequentially. It's important to note that a single workflow can contain multiple jobs that run independently or depend on each other. By structuring workflows with multiple jobs, developers can improve efficiency, ensure better task isolation, and enable more scalable automation for their CI and CD processes. For example, in a GitHub Action workflow, one job might run tests on the application code, while another deploys the tested code to a staging server. Each job runs independently or sequentially based on dependencies, ensuring a structured and automated development pipeline. The final core component of GitHub Actions workflows we need to explore are steps. Steps are individual tasks or commands that are executed as a part of the job within a workflow. Each step is executed in sequence within a job to complete specific tasks, such as building code, running tests, or deploying applications. Steps are beneficial because they break down complex workflows into smaller, manageable tasks, making automation processes easier to understand and maintain. They also allow for better debugging, as each step runs independently, enabling developers to identify and fix issues more efficiently. For example, in GitHub Actions workflows, one job might include steps for preparing the code, such as checking out the latest version from the repository. Another job could contain steps for running tests or deploying the application to a staging environment, with each job executing its steps sequentially. By structuring workflows into jobs and steps, you can manage complex processes with greater clarity and efficiency. Now that we've explored a GitHub Actions workflow, let's examine what's needed to activate it, otherwise known as an event. In the context of GitHub Actions, an event is a specific activity in the repository that triggers a workflow to run. Events ensure that workflows run at the right time without manual intervention, improving efficiency, consistency, and responsiveness in the development process. For example, when a developer pushes new code to the main branch of a repository, the push event can trigger a workflow that runs automated tests and deploys the updated application. This ensures that changes are validated and deployed seamlessly without manual intervention. Workflows can also be triggered manually on a defined schedule or by posting to an API. These manually triggered events ensure workflows run exactly when needed. In this video, you learned about the role and core components of GitHub Actions for automating CI/CD pipelines. GitHub Actions streamlines the development process by automating tasks like testing, deployment, and code analysis, reducing the need for manual intervention. This automation improves efficiency, consistency, and collaboration within teams, allowing developers to focus on writing code rather than managing workflows.
After you've created a web application, you can use GitHub Actions to process commands after you push your new code up to GitHub. In this screencast, we're going to demonstrate the process of writing YAML workflows for GitHub Actions to automate builds and tests. I have a very simple Node application here. It has a sum.js file, and all this does is just sums two numbers together and then returns the result. I've also installed a tool set called Jest, short for JavaScript test, and that allows us to create this test file so it can actually run the code that's in sum.js and then return whether or not that test passed or failed. I initialized npm in this project. I use this first command here in the terminal, npm init-y, and that just sets up our node server. And then I created a Git repository using git init. That's the second command in the terminal. We have a Git folder. I now have a local Git repository that I can store this code in. And then I've also installed this Jest toolkit using npm install jests, which is that third command there. So now I have everything set up. I've already added and committed files to my local repository, and I've also created a GitHub repository. I just call it GitHub Actions Demo, which is the same name as my project. And I've pushed all of those files to my GitHub repository. I've got everything set up now so that I can create this YAML file so that I can use GitHub Actions with this project. If I go back to GitHub, if I click on the Actions tab, there are no actions set up yet. I don't have anything going on in the Actions tab because I haven't created that YAML file. We're going to create that YAML file, and then we'll push the updates to GitHub, and then we can see how these workflows work. The idea behind the YAML file is you set up events, things to listen for on GitHub. One of the events we'll listen for is when we push new code. And then when that event is heard on GitHub, when that code is pushed, then the workflow will run. And you can do all sorts of automated tasks with the workflow. We're just going to do some simple things first, and then we'll see how they operate on GitHub. The first thing I need to do is to create a new directory. Let me get out of these commands. We don't need them since I already did them. The first thing I'm going to do is create a very specific folder called .github/workflows. This will create this folder in my projects. Created it there, GitHub Workflows. And now I'm going to create a new file, and I'm just going to call this ci.yaml. And our YAML file is what we use to create the actual workflows on GitHub. And I'm on Windows, so touch doesn't work. Let me start this over. I'll just create a new file up here called ci.yaml. If I were on Mac or Linux, I could use the touch command, but on Windows that doesn't work. We've got our ci.yaml file in our workflows folder, and now we can create the CI pipeline for GitHub that will run when we push these files. I'm going to create the entire YAML file, and then we'll walk through what's happening here. So in the first command, I give it a name, calling it CI pipeline. That could be anything you'd like. And then I give it the event. What I'm saying here is on any code push or pull request, these jobs that I've defined will run. The next item I have in my YAML file is a jobs category. And under that, I have a build action. For this build action, I give it a specific platform I want it to run on, Ubuntu latest. That's the operating system that will run on. And then I specify the steps. I'm going to use the checkout v2 action first. And then I give it a name for my next action, which is setup node.js. And then this is the setup-node v2 action that I'm going to specify for this workflow. And I'm specifying the node version I want it to operate on. What I'm doing here is I'm setting up my workflow by specifying the operating system and two specific actions. I'm letting it know that I want to use the setup-node action in node.js and what version I'm going to use. The next step in this workflow is to install dependencies. This is just a general npm command, npm install. I'm just going to make sure all the dependencies are available by running that installer. And then I'm going to run npm test in GitHub for my workflow. And this will all operate on the GitHub platform when I push any new code or there's any pull request made. So we can test this locally. I'm just going to run npm dev test. And because I've got that jest installed, it will run the test using jest. npm. You have to use the right command, of course. Now it ran that sum.test.js, that's this file here, and it passed the test. If we look inside of this tester, we have a test command, and we're telling the tester what it does. We expect sum of 1 and 2 to be 3. When we pass that into our sum operation, we're passing in 2 numbers, and then we'll return the result. Because that is what we had asked it to do, it passes the test, and we're using the npm command to verify that. Now, when we push this workflow, that will also run on the server side, and then we can test that there. Let's go ahead and add this one new file that I created to the repository. And then I'm going to commit this. Just going to say added YAML file. We added the YAML file and any of the other dependencies that we needed since we ran the application to our GitHub repository. And now we're going to push these to our origin. We'll use git push -u origin main. And that will push it up to the GitHub repository. Now I'm going to quickly go back to my GitHub repository. Under the Actions menu, we do have an action, which is the CI pipeline that created that YAML file. It added the YAML file, and the action is now queued, which means it's getting ready to run. We can open up that YAML file and edit it if we wanted to. This is just the build that's happening, and we can watch it work as it's going through the operations, the actions inside of that file. That action completed. If we go back to the actions, we get a green check mark, which means that the actions inside that YAML file, the ones that we specified, the workflow ran, and now it's updated and it's complete. Let's go back to our code and let's just change one thing. We'll change the test. We'll say 1.3 to be 4. We'll run that locally again just to make sure it works. And that passed. Now we can go ahead and git add. We'll commit updated test. And then we'll push to the origin. Let's go back to our workflow. Now we've got our updated test. That's what I just pushed into GitHub. That workflow is running again. I didn't have to do anything other than refresh the page just so that we could see it working. But I didn't have to do anything on GitHub because the YAML file defines the event that occurs when this workflow should run. It will actually run all the steps in that workflow. That will happen each time I push new code. It doesn't matter what code I push. On any push, this workflow will run. You can imagine you can do a number of things here. You can publish to your website. You can make sure that certain tests are done like we're doing here. You can make sure that data gets written to a database. Whatever you need to do in your workflow, you can define in that YAML file, and these operations will run automatically when the code is pushed or when there's a pull request. So that's a very simple way to create a workflow in GitHub, and you can do your own research on all the options that are available for these continuous integration pipelines. And there are a number of different things that you can do in your jobs to make your workflow easier.
In this lab, we're going to implement a basic CI/CD pipeline using GitHub Actions in VS Code. In step 1, we're going to set up our GitHub repository for the application that we're in. I'm in Visual Studio Code. We can do this in a shell command or shell file, which is what I have here, infrastructure.shell. We can also run these commands directly from the PowerShell terminal if we want to. I'm putting it in the infrastructure.sh file just because it's easier to read and we can talk through it easier here. In step 1, we're going to create and initialize the project. So we have our GitHub Actions lab. We're going to create a directory. We're going to move to that directory. And then we're going to initialize node in this folder. So we're going to use the npm init-y command. And that just initializes our node application for us. And then the next step is to initialize Git. We'll do git init. And that just sets up our project. So we're in our GitHub Actions lab folder, and we're installing npm and creating a Git repository in that folder. In step 2, we're going to define our workflow trigger. And for that, we're going to go to our ci.yml or YAML file. And the YAML file is what GitHub uses to trigger and run workflows in their DevOps subsystem. We're going to edit this YAML file. And the first thing we want to do is give it a name. We're going to call it CI pipeline. And then we want to give it some triggers. So when should this pipeline run? When should this workflow run? We want it to run anytime code is pushed or anytime there's a pull request. It's push or pull request for that item. That allows GitHub to know when to run the workflow. In step 3, we're going to add pre-built GitHub Actions to fetch code. For that, we go below our trigger, and we're going to enter a job item here. The job uses the build category, and we're just telling it runs on Ubuntu. And then the first step that we have here is that it's going to use this action/checkout, which will pull the code and allow us to use it in the workflow jobs. So that's the first step that we want to do, is make sure that our code is available for the workflow itself. And to do that, we use that action/checkout at v2. Now, finally, in step 4, we're going to set up node.js and run our tests. For that, we'll just add some more items to our step list. Go ahead and paste in these items. We give our first step a name called setup node.js. And then we have our uses actions/setup node. That's another GitHub action that we can implement here. We're setting up Node.js in our workflow environment. We're telling it which version to use. And then we can run node commands. We can run npm install. And then our final item for our steps for this workflow is to run npm test. Here what we're doing is allowing our workflow to perform specific actions using Node by installing Node first and then running the install command and the test command against Node on Ubuntu. And those are the steps for this lab.
Automating workflows and streamlining collaboration is no longer optional in modern software development. It's essential for staying competitive. Azure DevOps provides tools that not only automate deployments, but also integrate project management into the development process seamlessly. In this video, we will identify the core tools and services within Azure DevOps used for building automated pipelines. To begin, let's explore some key Azure DevOps tools, starting with Azure Pipelines. Azure Pipelines is a cloud-based service that automates the build, test, and deployment processes for applications, supporting continuous integration and continuous delivery, or CI/CD. It integrates with various version control systems and platforms, offering scalability and flexibility for projects of different sizes and programming languages. For example, imagine your team is working on a mobile app. Every time a developer updates the code, Azure Pipelines automatically tests it and deploys it to an environment for further testing and validation. This ensures the app is stable and ready for the next phase of development without manual intervention. Now that we've examined Azure Pipelines, let's explore another Azure DevOps tool, Azure Repos. Azure Repos is a set of version control tools that allows teams to manage their code using tools like Git. Azure Repos integrates with Azure DevOps, providing source control, collaboration, and code review features to streamline development workflows. For instance, when multiple developers are collaborating on a project, Azure Repos allows them to track changes, review updates, and merge their contributions seamlessly. This ensures the development pipeline works with a consistent and version-controlled code. Another key Azure DevOps tool is Azure Artifacts. Azure Artifacts is a universal package repository service that enables developers to manage and share code dependencies and packages from a centralized source. Azure Artifacts integrates with Azure Pipelines and other Azure DevOps tools, enabling seamless workflows for building and deploying applications with consistent versioned dependencies. For example, a development team could use Azure Artifacts to store a shared library that multiple projects depend on, ensuring all team members are using the same version. During an automated build in Azure Pipelines, the necessary package is retrieved from the Azure Artifacts feed and included in the application for deployment.
A final key Azure DevOps tool that we want to explore is Azure Boards. Azure Boards is a work management tool within Azure DevOps that helps teams plan, track, and manage software development projects. It provides features like customizable backlogs, sprints, and work items tracking, enabling teams to organize tasks, track progress, and collaborate effectively through the development lifecycle. For example, imagine a team creating a plan for developing a new app. Using Azure Boards, they can assign tasks, track progress, and identify potential issues in real time, helping the entire team stay on track and meet deadlines efficiently. In this video, you learned about the core tools and services within Azure DevOps used for building automated pipelines. Mastering Azure DevOps tools transforms complex manual workflows into efficient automated processes. By integrating these tools into your development lifecycle, you not only manage tasks, but also optimize your entire workflow for agility and collaboration.
GitHub provides you with a very powerful continuous integration, continuous deployment pipeline that you can use. But Azure also has a full DevOps environment, which gives you a lot more visibility into these CI/CD pipelines and a lot more options. In this screencast, we're going to demonstrate how to connect a GitHub repository to Azure DevOps for automated workflows. I have a Blazor application on screen here. It's just the template using Blazor Wasm template that I created. I didn't make any changes to the application for the purposes of this screencast, but I have a Blazor application that I've added to my own local GitHub repository. I've also added this to GitHub repository. So I've pushed this code up to GitHub and gave it the same name, Azure Web App, as the app that I have running. So I've got all of this wired up together. I can now push my code up to GitHub. But now I want to hook this into the Azure DevOps environment. So I'm going to switch back over to the browser. In this other tab here, I have an Azure DevOps screen up. You can see I'm at dev.azure.com. If that URL takes you to the Azure portal, you can just search for Azure DevOps in the search window. Then you can look at your own organizations. In Azure DevOps, you create organizations, and then under your organizations, you can create different deployments. My organization, I call Dev Project 2025, and I can put any number of CI/CD pipelines into this organization. And in this organization, I have a number of things set up so that I can work with my GitHub repository here. Any events that happen in my GitHub repository will be run through this pipeline environment. The first thing I want to do is connect my DevOps environment to my GitHub repository. I do that in settings. I went to settings down at the bottom. Under boards, there are GitHub connections. I'm going to click on that. I have my GitHub account connected to a very specific repository, Azure Web App, which is exactly this repository here. So now I have my DevOps environment for this project connected to that specific repository, which means that anything that happens in that repository will now be run through this DevOps environment. Now I can watch the actions occurring here and also monitor and look at reports and things like that. So I've got that set up, and now I'm going to go back to this side menu and go to pipelines. So the pipelines are where we define the specific things that we want to run when events happen in GitHub. You can create these CI/CD pipelines using YAML on GitHub itself. In this environment, we're going to work with Azure DevOps itself to create that pipeline. It can have a number of pipelines that I can create depending on my needs. For this environment, I'm going to define a very specific YAML file. I'm calling it Azure Pipelines for the purposes of the screencast. But this is defined very much in the same way as you would define a YAML file if you created one for your local GitHub. In this YAML file, I've got my categories, my trigger. I'm telling it anything that happens on Azure Web App in the main branch, be aware of that. I'm telling it what pool that I want to use. So in this environment, I have to create an agent that actually acts on my behalf in this environment. Since we're operating outside of GitHub, we have to create an agent, which I did in the background. You can define an agent that is hosted on Azure, or you can define actually your own agent that runs on your local machine and that interacts with Azure DevOps when needed. I created an agent pool on my local Windows machine, and I've connected that to this Azure DevOps environment, and I'm defining that here. The name of the agent pool is called default, and that will be called when I run my workflow. I'm telling it that the build configuration is release, and then I have my steps. My first task is .NET Core CLI at 2. I have inputs here to restore, and I'm giving it the project name so that it knows what command to run. So it's actually going to run the .NET restore command for that project. And then I'm going to do the same thing with build. It's going to run the .NET build command with a specific build configuration, and I'm giving it the project that I want it to build. And then the next task is to publish my project. So after it's been successfully built, it will then publish my project to the website that I have set up on Azure. So it'll automatically push the updated project to my website. I give it the path to where it should publish, the artifact name and the location. And then I'm telling it that I want to publish an Azure web app. And my Azure subscription is Azure Connect-MFST-web app. It's a web app type. The app name, this is the app name that I defined on Azure. It's called Microsoft Dev Web App. And then I give it the package that I'm going to send to the web app. So what I'm doing in this automation is I'm building the application, making sure all the dependencies are available, and then publishing it to my website. As soon as I do any activity in GitHub, publish some new code, this automation will run and automatically publish my website for me, so I don't have to manually do that. Now, what Azure DevOps allows me to do as well is to actually run this workflow independently of waiting for any events on GitHub. I can go ahead and run this. We can go back to the pipeline screen. That job is now queued. At any point when I've pushed code to GitHub, if I want to come into DevOps and just run that at any point, say I want to update the build for any reason, I can come into DevOps and just run this automation from the DevOps environment. This is now running. It's been running for now 11 seconds. And all of those tasks that I defined in my workflow are now happening. And what's happening in the background is that the code that I have on GitHub is checking for dependencies. It's being built and then zipped up. And then that zip file is being pushed to my Azure web app, where it will then be unzipped and published so that my users can get access to my application. So we'll let this run for a moment. That is completed, and you can see it took 1 minute and 43 seconds. I'll get the green check mark, which tells me that job is done. Now my site has been published to Azure. And I'm going to go ahead and open up another tab here, and we'll just browse to that site so you can see it operating. This is just the basic Blazor Wasm template, and that website is now available on Azure. It's all been published through this Azure DevOps pipeline that I defined. Using Azure DevOps gives you a lot more options and a lot more power. You can create a new project, establish a service connection to connect the project to a GitHub repository. You then configure an Azure pipeline using the pipeline tool to build that deployment pipeline. And then once the pipeline is built and you're running it, then you can monitor it right from this interface and watch the process for getting that workflow to run. There's a lot more options, obviously, in Azure DevOps. We've just covered a few of the options, but if you really need a powerful workflow environment, Azure DevOps is the way to go.
In this lab, we're going to implement a CI/CD pipeline using Azure DevOps and GitHub. So the first step is to set up an Azure DevOps project. I'm on the web here in the Azure DevOps UI, and I've selected to create a new project. And we're going to give this project name Weather CI Project. And I'm just going to put that in the project name. And then I can click create, and it will create that project for me, and I can get into this project and then make other changes as I need to. In step 2, we're going to add a GitHub service connection. In order to do that, I need to get into my settings. I'm going to click on this gear. Then I go under pipeline and click on service connections. And I'll create a new service connection, and it gives me the options here to choose the connection type. And I'm going to select GitHub. I can then go through the wizard and choose which repository I want to connect this pipeline to on my GitHub account. It'll have me log in, and then I can choose the repository that I'm interested in. For this project, I'm going to use the GitHub repository. In step 3, we're going to configure the Azure DevOps pipeline with YAML. For this interface, I clicked on the Pipelines tab here. When I click on that tab, I can choose Pipelines, and then I either need to create a new pipeline. I already had one created for this lab. And once you create the pipeline, then you can create or update the Azure Pipelines.yaml, or you can give it whatever name you want. I'm calling this Azure Pipelines.yaml. And here you can write our YAML file for our DevOps workflow. What I've done here is created a trigger. Anything that happens on the main branch, it will trigger the workflow. I'm using a VM image for Ubuntu latest. Then I have my steps below. But the important thing here for the trigger is that we are using the main branch as a workflow trigger. We want anything to happen for our workflow to include any changes made on that main branch. For step 4, we're going to push the code to GitHub to trigger the pipeline. In the background, you have to assume that I have an app here, and I have a GitHub repository for this app. And I have a remote application that's connected to my pipeline. That's the one that I selected when I chose GitHub as my repository provider. And I've connected that to my pipeline on Azure DevOps. Now I'm in my local Visual Studio Code folder with my application. And I'm going to add all the files to my Git repository locally by using the git add dot command. Add just puts everything that's in the folder that I'm currently in into my repository. And then I'm going to commit those changes, any additions that I've made or changes that I've made to those files using the git commit command, and I'm giving it a description, add pipeline configuration. And then finally, I'm going to use the git push origin main. So that's where I push the changes to my main branch, which we saw in the pipeline and the YAML file as well. Now we're pushing code to that main branch, and that should trigger the pipeline on Azure DevOps. In step 5, then, we can monitor the pipeline in Azure DevOps. For that, I'm going to go back to my web browser, and you can see all my pipelines here. And I've got a couple of previous runs. One failed for some reason. I can investigate that, and then this one completed successfully. But here I can see all of the runs that occurred within my pipelines for this project. I can investigate what happened there and why things went wrong. This is how you can use Azure DevOps and GitHub to trigger workflows and set up your workflow in the Azure DevOps environment.
Monitoring tools specifically designed for CI/CD pipelines plays an important role in maintaining their health by identifying issues early and keeping workflows uninterrupted. In this video, we will describe essential monitoring tools used to ensure the health of CI/CD pipelines. To begin, let's explore some tools for monitoring the CI/CD pipeline, starting with alerts, which can help you respond quickly to problems in your pipeline. In the context of CI/CD, alerts are typically generated by the CI/CD platform or monitoring tools integrated into the pipeline, and are automated notifications that inform developers of build failures, deployment issues, or performance concerns. Alerts help teams quickly identify and resolve problems, ensuring smooth and reliable software delivery. For example, if a deployment fails due to a missing configuration file, an alert from the CI/CD pipeline notifies the development team immediately, allowing them to fix the issue before it can impact production.
Similarly, if a security vulnerability is detected in a new code commit, an automated alert ensures the problem is addressed before the code is merged. After receiving an alert, it becomes crucial to examine the whole pipeline, and to do this we use dashboards. Dashboards are software tools or built-in features within CI/CD platforms that provide a centralized and visual representation of key metrics, build statuses, deployment progress, and system performance. Dashboards offer an interactive interface, enabling developers to track trends, optimize performance, and ensure smooth software delivery. For example, imagine a dashboard displaying the status of multiple pipelines in a single view, highlighting which builds are delayed or failing most frequently. By discovering a recurring failure in a specific branch, the team can quickly investigate and resolve the underlying issue, preventing further disruptions to the development cycle. While dashboards offer a summary, sometimes you need specific details to solve a problem, which is where audit logs come in. Audit logs are software tools or built-in features within CI/CD platforms that track and record all significant actions within the pipeline. These logs provide a chronological history of events such as code commits, build triggers, deployment changes, and access modifications, ensuring transparency and accountability. By maintaining a detailed record, audit logs help teams troubleshoot issues, enforce security policies, and meet software development and deployment compliance requirements. For example, if a deployment fails unexpectedly, an engineer can review the audit logs to identify who made the last code change and what modifications were applied. Similarly, in a security review, audit logs can help track unauthorized access attempts or configuration changes within the CI/CD pipeline, ensuring compliance with internal policies. In this video, you learned about the essential monitoring tools used to ensure the health of CI/CD pipelines. Monitoring tools like alerts, dashboards, and audit logs form the foundation of a reliable CI/CD pipeline. When used together, these tools ensure that software delivery remains efficient, predictable, and resilient to failures.
Once you've created a CI/CD pipeline, it's important to occasionally review it and make sure that you have everything up to date. You can also modify your pipelines to do more work for you to make your pipelines a little bit more robust. In this screencast, we're going to explain techniques for maintaining CI/CD pipelines to ensure reliability over time. So I've got a simple Blazor application here. It's just using the Blazor Wasm template. I haven't made any changes to the application. It's just a demo for the purposes of the screencast. But I've created that application. I've also created a local Git folder and added and committed the code to that Git folder. And then I've created a GitHub repository. I've called that Azure Web App. And I pushed the code from my local Git repository to this GitHub repository so that I can interact with Azure DevOps. So I've got all this kind of wired up together. And now I want to go over to Azure DevOps and look at the CI/CD pipeline that I've created for this project. The first thing I did was I connected GitHub to this project. So if I go into my settings for my organization, I have the Azure Web App GitHub repository connected to this project so that any of the pipelines that will run for this specific GitHub connection. And then I have a pipeline already defined, and I'm going to go into this pipeline and edit it. I'll click edit on that specific pipeline, and it opens up the YAML file that is associated with that specific pipeline. Now, as I look at this YAML file, I want to just make sure that everything's up to date. I have no errors in the YAML file, but as I look at the steps here, I notice that I'm using .NET Core CLI version 1. I know that version 2 is actually the latest, so I'm going to go ahead and change this to 2 and make sure that I'm using the latest version. So occasionally you may need to do that. If a new version of the CLI comes out, you may want to update your pipeline to reflect the latest version, particularly if the new version has bug fixes or if there's some new features that you want to make sure that you can take advantage of inside of that new CLI. So I'm going to go ahead and update that to version 2. And then I'll click validate and save, and Azure will actually make sure that your code inside of your pipeline is valid. It won't let you save it if you have invalid code. It's going to save now this new version of my YAML file. and now I'm ready to go. That was one minor change that I knew I wanted to make. Now, suppose I wanted to make this automation script a little bit more robust. I'm setting some parameters, defining what I want to do in this workflow, and then I'm restoring the project, making sure all the dependencies are there, and then building the project, and then I'm publishing it to my Azure web app that I've defined on Azure. What if I want to have some automated rollbacks so that in case something goes wrong, the build won't fail and I can go back to a working build? This is important, particularly when you're working with automation, because if you let this run in the background and you don't monitor or you forget to monitor it, you want to make sure that your website always has a working build. I'm going to replace a section of this code with code that will actually roll back in case something goes wrong. So I replaced the steps section with two different stages sections. I have stage build and stage deploy. I've broken those steps out into two different stages. I've got a build job, and I've got a lot of the same things going on here. I've got the restore operation, the build operation, and then the publish operation. When it hits that deployment stage, when it's ready to push to the website, I am telling it that I want to push it to production. I want to download the current item and drop the artifact. And then I'm going to tell it what subscription that I'm using on my server, the app type, and the fact that I'm going to use this Microsoft Dev web app service on Azure to push my website. So that's very similar to what I had before. I've just broken it out into two stages here. And I've also added this one other item that's really important. Now I've got an event. If the Azure DevOps workflow detects a failure, then I'm going to write out to the console that I'm rolling back to the previous build, and the DevOps application will roll back if I add the code there. Now, at this point, I'm only notifying that it needs to be rolled back, but I would want to add code here to go back into GitHub, pull out the last working build, and then publish that to my website so that my website doesn't have a broken application on it. But this on event will allow you to do that, not only to detect the failure, but then to roll back to a working build. By making that changes from just the individual steps like we had here to these different build stages, I'm able to now do more with my workflow and make my workflow a little bit more dependent, a little bit more robust. Okay, let's do one other thing. I'm going to go back to my application. I'm going to add a file that will go out to NuGet and regularly check for updates to any dependencies that I have in my project. In order to do that, I'm going to create a new folder called GitHub.github. Put that in the root of my application. And then I'm going to create a file, we'll call it dependabot.yaml. So I'll create this called. All right. So now I've got my YAML file, and I'm going to write a code that will cause GitHub to regularly run a NuGet package update on a regular basis. I'll paste this code in. Here I'm going to say that the package ecosystem that I want to use is NuGet. I want it to apply to any dependency in my project, and I want it to be run every week. I've given it the updates keyword so that the automation knows what I actually want it to do. I can push this now to GitHub, and I can ensure that every week GitHub will run that automation and check for dependencies so I don't have to do that manually. Now, obviously, you want to be careful here because if you're depending on a specific version of a package, you'll want to update your dependabot.yaml file to not install certain packages if they need to be tied to a specific version. But for the most part, making sure that your dependencies are up to date will address any bugs or catch any fixes that you need to address. So these are different ways that you can modify your automation. You can do it through GitHub directly, or as we did, you can go into Azure DevOps and you have a lot more options and a lot more robust ways of addressing your workflows so that they're always up to date and that you're taking advantage of all the automation opportunities that Azure DevOps provides.
Understanding how CI/CD pipelines automate and optimize software development is essential for back-end development. These practices improve efficiency, reliability, and scalability, ensuring that applications are continuously integrated, tested, and deployed with minimal manual intervention. We started by exploring the fundamentals of continuous integration and continuous deployment, CI/CD, examining how these practices enhance back-end development by automating testing, code integration, and application deployment. Next, we explored how CI/CD pipelines streamline deployment workflows, analyzing their key components and best practices to facilitate efficient, dependable, and scalable application releases. Then we examined the process of setting up GitHub Actions for CI/CD, discovering how to design automated workflows that streamline code integration, testing, and deployment within GitHub's ecosystem. After that, we analyzed how Azure DevOps enhances CI/CD pipelines, enabling automation of development workflows, streamlining release management, and fostering seamless collaboration among development teams. Finally, we explored strategies for monitoring and maintaining CI/CD pipelines, exploring effective techniques for tracking performance, diagnosing issues, and ensuring a smooth, continuous software delivery process. Mastering CI/CD pipelines is essential for delivering reliable, efficient, and scalable applications. Applying these automated techniques will enhance development workflows, streamline deployments, and ensure continuous software delivery with confidence. Welcome to Application Monitoring and Maintenance. Effective monitoring and maintenance are essential for ensuring applications' reliability, performance, and security in a cloud environment. Mastering these skills will help you identify issues early, streamline operations, and keep applications running smoothly. We will begin by examining the fundamentals of application monitoring, examining why it's essential for maintaining performance, identifying issues, and ensuring system reliability in backend development. Next, we will explore Azure Monitor and learn how to use its powerful tools to track application performance, detect anomalies, and gain real-time insights that drive proactive decision-making. Then we will focus on best practices for logging and log management, uncovering effective strategies for capturing, organizing, and analyzing logs to troubleshoot issues and optimize system performance. After that, we will explore how to automate routine maintenance tasks in Azure, streamlining operations with automation tools to reduce manual effort, improve efficiency, and enhance system stability. Finally, we will identify best practices for maintaining applications in Azure, examining key strategies for long-term application health, security, and performance optimization. By the end of this module, you will have the knowledge and skills to proactively monitor, maintain, and optimize applications in Azure. Let's get started with application monitoring and maintenance. Today's user experiences are driven by modern applications that must be able to perform under pressure. Monitoring application health and performance ensures your systems remain reliable and responsive, even under real-world production conditions. In this video, we will identify key techniques and tools for monitoring application health and performance. To begin, let's explore common monitoring techniques and tools for keeping applications reliable, starting with real-time monitoring. In back-end development, real-time monitoring refers to continuously tracking the performance, health, and status of various application server-side components. Real-time monitoring can be implemented using tools like Azure Monitor, a powerful tool for monitoring applications running in Microsoft Azure. Azure Monitor allows you to assess live metrics, configure alerts for critical thresholds like high memory usage, and display data on dashboards. For example, imagine an alert from Azure Monitor notifying you of an extreme increase in CPU usage. Addressing it promptly prevents user delays and keeps the system operating smoothly. While real-time monitoring identifies immediate issues, log monitoring analyzes past data to uncover patterns and root causes. Log monitoring is the process of collecting,
analyzing, and tracking log data from applications, servers, databases, and network devices in real time. It helps backend developers detect errors, troubleshoot issues, and gain insights into system performance and security. Log Analytics, a tool in the Azure Monitor portal, allows you to edit and run log queries to analyze collected logs effectively. By centralizing logs with Log Analytics, you can easily spot recurring issues, such as timeout errors during peak hours, ensuring no critical pattern goes unnoticed. For example, a company might use Azure Monitor Log Analytics to track API request logs, identify slow response times, and automatically trigger alerts for failures. Real-time and log monitoring focus on maintaining system health. However, application performance monitoring, or APM, provides a clearer understanding of the system's performance. Application performance monitoring is a set of practices for monitoring and managing the performance and availability of software applications. It involves tracking various metrics such as response times, error rates, transaction traces, and resource usage to ensure that the application runs smoothly and meets user expectations. Azure Monitor, with its Application Insights feature, plays a central role in application performance monitoring by enabling real-time collection, visualization, and analysis of performance data. For example, a development team can use Azure Monitor Application Insights to track the performance of their web application, identifying slow API responses and database queries. The team can set up real-time alerts in Application Insights to automatically notify them when an error rate exceeds a certain threshold, allowing for immediate troubleshooting. In this video, you learned about key techniques and tools for monitoring application health and performance. Understanding monitoring techniques and tools equips you to detect and resolve performance issues before they affect users. By integrating these practices into your workflow, you'll ensure your applications remain reliable, high-performing, and ready to meet the demands of dynamic production environments.
Once you've created a back-end website, it's important to continually monitor it to make sure that it's performing optimally and to look for specific data that might indicate that something's going wrong that you may need to fix. So in this screencast, we're going to explain how monitoring metrics reflect the health and performance of back-end systems. I've got a simple ASP.NET API set up here. It's just a simple web weather forecast application. You can see I have a single endpoint called map.get at the weather forecast endpoint. And all it does is simulate weather data. It will return weather data in JSON format randomly. It also simulates hogging memory and sleeping, so simulating various response times. So this is just a simulation for what a specific weather forecast endpoint might look like. I've added this to a local Git repository and also pushed this up to GitHub. And I have this running on an Azure web app. So you can see here's the web app. It's actually running in real time, and it's located at this URL. So I've got all of this set up now. And when I set up this web app, I also set up Application Insights. Application Insights regularly gathers data about your website, and it gathers a number of different points of data that you can analyze and look at to see what's going on with your website. So let's go over to Application Insights. I've got this actually tied up to my website here. This is the Monitor demo website that we saw here in this other tab. We're actually looking at the data that Application Insights has collected over time. There's not a lot of data here because this is a demo application and I just refreshed the application multiple times just to show how it works. But you can see that it's collecting data. I've got the events tab pulled up here and you can see how many events occurred on this app over the last 30 minutes. I just set the time frame to 30 minutes. If I set it over for the last hour, we get a little bit more data here. But you can see that it's collecting data about how many events occurred and what's going on with my website in terms of events. I can look at that over time. It gives me a different view of the data and see how many events are occurring. If I click this View More Insights button, I get even more rich data. So here I can see where the traffic is coming from, which operating system possibly, and which browser version that traffic is coming from. I can also see all the endpoints or all the assets that are being hit by users or being pulled from this event. I can do the same thing with sessions. I can get session data, so how many sessions occurred in a given period of time. here's all the session data for the last 24 hours, and I can get even more rich data on sessions as well. So Application Insights just gives you a lot of interesting data for analyzing your site, and it can tell you what's actually happening, what's going on. Let's go over to this Live Metrics tab. We can actually watch Application Insights collect data in real time for our application. So you can see there's nothing really happening here at this point, but I'm going to go to the running application. This is the endpoint, the weather forecast endpoint on that Azure website that I created. And I'm going to refresh the page a few times and let it send some traffic to Application Insights. You look at that, you can see that there's an error that occurred, and hopefully that will show up also in Application Insights. We can actually look at these errors occurring. Now, this is probably occurring because I set those limits in that memory hog line item in the application. So I'm actually getting errors. Now you can see here that Application Insights is producing that real-time data. You can see the request rate, the duration, and also the failure rate. Now, if this were a live site and I saw those 500 errors, I would definitely want to investigate that. I've simulated those errors in the application, but in a real world application, if you saw a lot of those over time, you might want to fix those or look into what's happening there. Notice that Application Insights also tells me about how my application is operating from a resource perspective. I can see how much committed memory it's using, the total CPU that's happening, and how many exceptions are occurring. Notice that if this CPU number spiked, if I was getting a lot of requests and a high CPU rate, I would want to look into that. Is someone trying to attack my website and causing the CPU to spike or the request rate to spike? Or is it just my application is very popular and a lot of people are using it and I'm getting a high CPU count? If that's true, I may want to think about upgrading my service plan so that I can handle all the traffic that my website is giving. So using a tool like Application Insights with your website, whether it's a site itself that is disseminating information, or if it's an API where people are gathering information from that API to do other things with it, you want to make sure that your application is running well, and Application Insights can give you the data that you need to make good decisions and improve things that need to be improved.
Each moment of downtime or poor performance while using an application can frustrate users and even result in lost revenue. Azure Monitor equips teams with the tools and insights they need to maintain high-performing, reliable applications, ensuring a seamless experience for users. In this video, we will identify the key features of Azure Monitor that enhance application visibility. To begin, let's explore some features in Azure Monitor that can help offer a great user experience. We'll start with alerts, a feature designed to notify users when an issue arises. Recall that alerts notify you when Azure Monitor detects potential issues in your application or infrastructure, using set thresholds on metrics or log data. Alerts in Azure Monitor enable faster response times, reducing downtime and ensuring applications and infrastructure remain reliable and efficient. For example, if your web server's CPU usage spikes over 80%, it could lead to slower application performance. By using Azure Monitor, your team is notified in real time via alerts if there is a performance concern, allowing you to address the issues before users experience disruptions. Once you've set up alerts to catch specific issues, the Azure Monitor dashboard provides a comprehensive, real-time display of your application's key metrics. Recall that dashboards are software tools or built-in features within CI/CD platforms that provide a centralized visual representation of key metrics, build statuses, deployment progress, and system performance. By utilizing Azure Monitor dashboards to display real-time insights, teams can quickly identify trends, detect anomalies, and make data-driven decisions to optimize system performance. For example, imagine noticing a sudden spike in error rates or the CPU being overloaded on your dashboard. This allows you to quickly investigate and resolve the problem before it escalates, helping maintain user satisfaction. While dashboards give you an overview, Application Insights goes further, offering detailed performance tracking and insights into user interactions. Application Insights is an application performance monitoring service in Azure Monitor that helps developers detect, diagnose, and optimize application performance and reliability. It provides deep insights into errors, response times, and dependencies,
enabling teams to optimize application performance and improve the user experience. For example, if users frequently abandon the checkout page, Azure Application Insights might reveal a slow-loading payment feature that could be preventing customers from completing their purchases. Addressing this issue improves both user experience and conversion rates. In this video, you learned about the key features of Azure Monitor that enhance application visibility. These features ensure your applications stay reliable, high-performing, and capable of delivering the experience your users expect. Azure Monitor gives you a lot of tools that you can use to gain insights into how your applications on Azure are performing and whether there are any issues. In this screencast, we're going to demonstrate how to set up alerts and dashboards in Azure Monitor to track real-time performance. So I have a simple web app here in Azure. This is a demo app, so it doesn't get a lot of traffic, but there is some data here that it's collected over time. I'm on the overview section on the left-hand side. On the monitoring tab of that overview section, I get some metrics that I can look at to see how the app is doing in general. I can see HTTP5X errors, data in, data out, and things like response time and other items, how many requests were made and all that. It gives me some basic data for my app. If I wanted to go deeper, I can go to the monitoring section of my web app, and I can set up even deeper diagnostic settings. If I click on that section, I can go deeper on the diagnostic settings and get richer metrics. There's a logs tab on the dashboard here that I can quickly take a look at, but I can also set up numerous logs. In this screencast, we're going to look at alerts. Alerts allow me to get notified if something isn't going with my application. The first thing I want to do is set up an alert rule. The rule defines what I will be alerted about. What's the condition under which the alert will fire? I'm going to create an alert rule. The first thing it's going to give me is the condition. I'm going to select a signal. This is the trigger that's going to fire off the alert. I'll create that signal, and we'll just look at response time. I'm going to create this signal called response time. By default, Azure Monitor will use a dynamic range. It's going to look at the average over time. It's going to look at whether or not the threshold is greater than or less than. So was the value of that average greater than or less than? And then it's going to give me a sensitivity of medium. It's going to figure out kind of an average for what the response time should be for an app, the parameters that I've set for my app, and then send me an alert or create an alert if it's greater than or less than that average. Now I can also go in and set a static number. So here I can say if the average is greater than, let's say 2 seconds, if the response time is greater than 2 seconds over a specific average, then I want this alert to fire. It also gives me the option for how often to check, defaults to checking every minute, and it has a look back period of 5 minutes, which is going to use when calculating that average. Over the period of the last 5 minutes, if the average response time was greater than 2 seconds, then create this alert. So now I've got my trigger. And the next thing I'm going to want to do is create an action. So now that I've got the condition set, I can create that action, which is going to tell Azure what to do in response to that condition being met. Once the condition is met, send me an email. Once the condition is met, show me in the Azure portal, provide an alert in the Azure portal, or any number of things. So I can create those actions here. I can add some details about what resource groups I want to use, create some tags so I can sort and find this later. And then when I'm satisfied, I click Review plus Create, and it will give me the opportunity to review all the settings and then create a rule based on this condition. Now notice I can create as many alert rules as I want for all different types of conditions. I can actually have multiple response time rules in my rule groups and set different check periods and look back periods and do whatever I need to do to make sure that I'm getting alerted when I need to get alerted. So alerts are very powerful. You can get very specific on how these alerts are created, and it will make sure that you're never unaware of specific conditions and specific things happening on your site. Now that we have an alert created, let's look at creating a dashboard so that you can actually have one single place that you can go to look at all of your metrics and even see your alerts. So I'm going to type in dashboard in the search box here, and it's going to take me to Dashboard Hub. Now, Dashboard Hub shows me all of my dashboards. You can see in this subscription, I only have one dashboard created. That's where I have all my resources and other things. So I'm going to create a new one, and there's some templates that it provides for me. I can start with a blank dashboard and add anything that I want to it, but it also has an application insights dashboard, which will allow me to see metrics related to the health and performance of my application. I'm going to click on Application Insights and create a dashboard from there. Okay, so now I'm in the dashboard creation screen. I'm going to give it a name. I'll just call this App Metrics. And then it asks me what subscription I want to use. And then I can also select the resource. I'm going to use the Monitor demo resource that I have set up already. Okay, so now I've got my dashboard name, my subscription, and my resource selected. So now I can click Submit, and it will create that dashboard for me. And it shows me different aspects of my application metrics. I can use this to have insights into what I want to track for my applications. I can also modify this. I can edit this dashboard, and I can add different resource groups, different resources from those groups. And so I can make this dashboard as specific as I want to make sure that it's giving me the data that I'm looking for when I come to this dashboard. I can also use filters to modify how individual tiles on this dashboard respond when I come to the dashboard. So Azure Monitor and Azure Dashboards give me a lot of flexibility and a lot of opportunities to gain insights into how my application is doing as I'm working with it. And not only a single application, but from a dashboard, you can have multiple applications to get insights into how your websites are doing or how your web apps are doing. By using these tools in Azure Monitor and using dashboards on Azure, you have the tools available to you to make sure that all of your applications that you're running through the cloud are performant and meeting user expectations.
Logs assist production systems by capturing key events and interactions to ensure smooth operations. Using logging strategies, you can turn log data into actionable insights, helping systems run efficiently across multiple environments. In this video, we will identify key strategies for logging and log management in production systems. To begin, let's explore some core logging strategies, starting with centralized logging. Centralized logging is a system that collects, aggregates, and stores logs from multiple sources, such as applications, servers, and cloud services, into a single platform for easier monitoring and analysis. It enhances access to insights, simplifies troubleshooting, and improves security by providing a unified collection of system activity across an entire infrastructure. For example, rather than manually reviewing logs on individual servers, centralized logging allows you to forward them to a platform like Azure Monitor. This central point allows you to efficiently search for errors, saving time and effort while improving access to insights across your systems. Once your logs are centralized, the next priority is to ensure they are easy to analyze, which is where structured logging comes in. Structured logging formats logs into key value pairs, allowing each log entry to be easily queried, filtered, and analyzed. This makes it easier to search, filter, and analyze logs for debugging, monitoring, and security purposes. For example, a company might use structured logging to track user activity across its website by logging each interaction with key data points like user ID, page visited, and timestamp. This structured data could then be analyzed to identify patterns, detect anomalies, or optimize user experience. After centralizing and formatting logs, it is crucial to manage how logs are stored, which is achieved through retention policies. Retention policies are rules that define how long data, such as logs, backups, or documents, should be stored before being archived or deleted. Retention policies help organizations manage storage costs, comply with regulatory requirements, and ensure that only relevant logs and data are retained for future reference. For example, a company might implement a retention policy to keep error logs for 90 days and archive them after that period for compliance purposes. This ensures that recent logs are readily available for debugging, while older logs are stored secretly but not taking up unnecessary active storage space. After implementing your logging strategies, it's important to ensure they continue to work effectively over time. So you must continually monitor and audit them. Monitoring your logging strategies helps detect issues, such as a server failing to send logs, while auditing your logging strategies verifies that logs include critical details, like timestamps and error severity. For example, with tools like Azure Monitor alerts, you can monitor your logs in a central location and be notified if problems occur immediately, ensuring quick resolution. You can also use it to schedule audits to help keep logs well organized and compliant within system requirements. These steps maintain the integrity and usefulness of your logging system. In this video, you learned about key strategies for logging and log management in production systems. Effective log management can be implemented by applying centralized logging, structured logging, and retention policies. These strategies transform scattered log data into a powerful resource, ensuring production systems remain reliable, efficient, and easy to troubleshoot.
Logs can be very powerful tools to assess the performance and the health of your applications, but you have to know how to use the log data and be able to manage the log data. Just writing log data out can get unwieldy. So in this screencast, we're going to demonstrate how to use logs to identify performance issues and even ensure compliance. So I've got a simple Node application here, and I'm going to use a couple of libraries. I've got the Express library set up, and then I'm also using this library called Winston. Winston is used for logging, and we'll use Winston to be able to capture and create a log for our little website here. This website doesn't do very much. It just has a GET route. When you hit the base URL, it's just going to return hello world. But we're doing a couple of things here. We're going to create some logs. So we're capturing some log information, and that log information is going to be written out to the console so we can watch in real time as things happen on our site. And then we're also using Winston to be able to create that information as it's coming in. For right now, all we're going to do is log directly to the console, and we're going to create this route at the base URL. And let's go ahead and run our application. We'll do node index.js. We got our first log message. So this is JSON format. They're key value pairs. You can see that we've got a level as the key, and then the value is info. And then the message is the key, and the app listing and port 3000 as the value. So we get some key value pairs. JSON is very easy to work with for other tooling. So this is a great way to capture log information. Let's go ahead and go to our local host on 3000, and I'll go to that site, and we should see hello world when we hit this URL. There's our message from our website. Now, if we go back to the website, we will see that log message created. So we've got now a level of info, the message request completed, the method was get, and we got a status of 404 favicon. That means that it was looking for a specific thing and it wasn't there, so it gets a 404. The other message where we actually use that get route is here, and that was a 304, and the request was completed. It tells us information about the traffic that's happening on our website. So if I were to refresh this a few times, we'll see a message for each time I refresh. So we get that message back. The request was completed, and here's the route that was hit, and now we can see some good information. This logging really does help us understand what's happening on the site. Now, it's not super helpful only because it is being done in the console. This information isn't being captured anywhere, and we can't do anything with it once the app closes down. We'd have to copy and paste out of the console. So I'm going to rerun this application, and I'm going to use this pipe character. So that's this item here. And I'm going to tell it to write out the log information to a file called logs.json. Now it's actually going to capture that information in a file that will save until the session completes, which can be very helpful. So we can get information now in a file, we can put that in a different tool and do different things with it. I'm going to go ahead and run this application again. I get that message in the console, but I'm also getting it logged here to logs.json, and it's the same information. If we go back to our website, I'll refresh it a few times. And then if we go back now to our application, that logs.json is being updated with the same information that we're capturing to the console. So now we have a file of that information being saved to our file system, which can be very helpful when we want to do analytic work. Let's go back to our index.json file. All we had to do was use that pipe character, use the T command, and then give it a file name. That could be anything, but we gave it the file name logs.json. Now, what if we get errors on our site? The Winston framework will allow us to capture those errors. I've got another route here called error/error. We're going to essentially use the logger.error method to track that error as it occurs. So we're essentially faking an error. This is just a route that allows us to create an error manually so we can see how the logging would work. The error is going to be something went wrong. It should tell us that. And then it's going to give us a status of 500, which is the status of internal server error. So we should see those reflected in our log. Let's go back to our website and we'll put in that route. We get back internal server error. That's pushed out to the user so the user knows something went wrong. And then back in our file here, we get that error message here and in our log file as well. Now we get the error and it's telling us exactly where and how the error occurred. So we get that information now here in our log file, and we get it back in the console, and we even get some very specific information about that error in the file. So that's very helpful information, and as things do go wrong like that, you can analyze that information and figure out what exactly is happening. The last thing we're going to do is update our Winston command to provide some more data when we're creating a log file. So I'm going to stop the application, and I'm going to go up to the logger variable, and I'm going to change the Winston command to include more data. Let's just suppose for compliance reasons, we need to log the timestamp, and we need to have formatted JSON in our file. So I'm going to add those commands to our Winston object. We'll get some more detailed logging. We'll go ahead and run our application again. I'm going to go back to our localhost 3000. We'll see hello world there. And I'm just going to create a few more log entries. And then when we go back to our log file, we have it here in the console. And if we look at our logs.json, you can see now we have a timestamp included in our log. It gives us the date and time. That just allows us to do more with our log file, so we know exactly when these requests were made. And we can add more items in our index.json file. We can continue to add items here as needed for compliance or whatever. This is just a simple way in a Node application how you can use logging to get more robust data on what's happening on your website. Once your logs are in a JSON format, you can put those into other tools and do more with that information. So you can make sure that your website's always running at the most efficient and running without errors. Automation is a powerful tool for taking on back-end processes. It reduces repetitive tasks, improves efficiency, and frees up time for strategic work. By using Azure's automation, you can streamline operations and focus on what really matters. In this video, we will identify the key automation services available in Azure for managing maintenance tasks. To begin, let's define Azure Automation and explore the services it provides to automate administrative tasks like backups and updates. Azure Automation is a cloud-based automation platform that enables users to automate repetitive tasks, manage configurations, and orchestrate workflows across Azure and hybrid environments, like those that include both on-premise data centers
and cloud-based resources. Azure Automation includes features like process automation, configuration management, and update management to improve operational efficiency and reduce manual effort. For example, instead of manually applying updates, you can schedule them to happen automatically using Azure Automation. This ensures consistency and saving time for other work. Now that we've examined what Azure Automation is, let's explore some of the services it provides to manage tasks, starting with its Logic Apps service. Azure Logic Apps is a cloud-based service that enables users to automate workflows and integrate applications, data, and services across cloud and on-premises environments. It provides a low-code, no-code interface to design workflows using pre-built connectors, which makes it easy to automate business processes like data synchronization, notification, and API integrations. For example, imagine you're completing a maintenance task and need to inform your team. Azure Logic Apps can automate this process by sending a notification email immediately, keeping everyone updated without requiring manual effort. While Azure Logic Apps is useful for connecting services, there are also scenarios where automation involves repetitive, system-specific actions, which is where Azure Runbooks comes in. Azure Runbooks can be used to automate frequent tasks through predefined scripts, tasks such as system maintenance, incident response, and cloud resource management. They can be written in various ways, such as with Python, allowing users to automate complex operations, reducing manual effort, and enhance efficiency across Azure and hybrid environments. For instance, restarting a web application after updates can be handled seamlessly using an Azure Runbook, reducing downtime and ensuring operational efficiency. Some situations require automation that responds instantly to specific events, and Azure Functions can make a big difference in these situations. Azure Functions is a serverless computing service that enables developers to run event-driven code without managing infrastructure. It allows you to execute small, independent functions in response to events such as HTTP requests, database changes, or message queue triggers, scaling automatically based on demand. This makes Azure Functions ideal for automating workflows, processing real-time data, and integrating different cloud services efficiently. For example, if server CPU usage exceeds a critical threshold, Azure Functions can trigger an alert instantly, enabling you to address the issue before it impacts performance. In this video, you learned about the key automation services available in Azure for managing maintenance tasks. Azure Automation Services simplifies back-end operations, improves reliability, and saves time, allowing you to focus on the work that creates a great user experience.
Runbooks on Azure allow you to automate a lot of routine tasks. And you can use PowerShell scripts in runbooks. PowerShell is a very powerful scripting language, and you can use PowerShell to automate those tasks. In this screencast, we're going to demonstrate how to create and use runbooks to automate routine tasks in Azure. I'm in my Azure account. I got an automation account set up, and it's called Developer Automation. And it's just one of the services that you can find from the resource toolkit. If you search for automation accounts, you can go to that service, and then you can set up your automation accounts. I've got that automation account set up, and now I'm going to go into my Developer Automation account, and I'm going to be able to set up a runbook. And a runbook will allow me to create a very specific script so that I can automate some tasks. The first thing I want to do is go into Process Automation and then click on Runbooks. I've got a couple set up here already, but I'm going to create a new one. And I'm going to call this runbook, I'll just call it Shutdown VMs. This will allow me to shut down any VMs that's in my resource group. The runbook type is going to be a PowerShell runbook. I'm going to use an existing runtime environment. I'll just use the latest version of PowerShell, and I'll click select. Now I've got PowerShell 7.2 running, and I've got my name and the type. Now I'm not going to go through and create tags or anything. I'm just going to review and create, and I'll create that runbook. Now Azure is deploying that runbook to my subscription. And once I get the runbook up and ready to go, I'm in Shutdown VMs. Now I can go ahead and edit that runbook, and I'm going to paste in a specific script to shut down any VMs that are on my resource group. I'm going to paste this in. Here I'll put my resource group name, and this would actually be a real resource group name here. It will list any VM that's in my resource group, and for each VM that's in that list, I want to set the power state. I want to evaluate whether the power state is equal to running. If it is, then I'm going to stop that VM. It goes through the entire resource group and stops any VMs that are actually running. And you can see the value of a script like this where it's running one script to stop all those VMs. Now I'm going to publish this runbook, and I can schedule this runbook to complete at different points. I can actually have it run on a schedule so I don't have to go into the Azure portal or get into the command line to have it run. That's also very powerful. Okay, so let me refresh this to make sure that this is up and ready to go. I've already had this runbook with this name in the past. I've run it a number of times. I was making some changes and a couple of times it failed, but it gives me some nice status for each item where it's run. And if you go into any of those individual runs that I did, you can get input, the output, any errors that occurred, warnings, see all the logs and any exceptions that occurred. For each run, you can get all that data, and then you can evaluate how your runbook is accomplishing its task. Runbooks are very powerful ways to automate tasks on Azure. I just gave a simple example of shutting down VMs, but you can imagine you can do a lot of different things. You can have a runbook clean up data once a week, remove archive data, move data from one database to another. You can have it scan for security issues. Anything that you can do with PowerShell against Azure using the Azure command line interface, you can do in a runbook, and that makes runbooks very powerful. You can also see that there's scheduling and webhooks. Webhooks are event trigger-based activities. When you ping a webhook, you can actually have these runbooks run, or you can have it actually linked to a schedule so they're running on a regular basis. As I said, runbooks are very powerful ways to get routine tasks done in Azure. Hackers and malicious software are always searching for vulnerabilities to exploit. Regular updates and patching are your strongest defenses against these threats, ensuring your applications remain secure and protected from emerging risks. In this video, we will explain the importance of regular updates and patching for maintaining secure applications in Azure. To begin, let's explore some key updating and patching practices that help keep your system secure, starting with automated patching. Automated patching is the process of automatically applying software updates, security patches, and bug fixes to systems, applications, and infrastructure without manual intervention. Without timely updates, systems can become easy targets for attackers. To avoid this, developers can use Azure tools to schedule updates and apply patches automatically, addressing vulnerabilities quickly and efficiently. For example, imagine supporting an e-commerce platform. Using Azure tools, you can schedule automated weekly patches during off-peak usage hours, ensuring critical updates are applied without impacting operations or customer experience. Now let's explore another key update and patching practice, service updates. Service updates refers to enhancements, bug fixes, security patches, and new features released by a service provider to improve the functionality, security, and performance of a cloud service or software platform. These updates help ensure systems remain secure, optimized, and aligned with the latest technological advancements. Using Azure tools, these updates are applied automatically to Azure resources such as databases and app services. For example, an IT firm regularly implements service updates using Azure tools to introduce new features like advanced analytic tools to enhance functionality. These updates also include performance improvements and bug fixes to ensure a smoother user experience. Finally, let's explore the key practice of patch compliance. Patch compliance refers to the process of ensuring that all systems, applications, and devices within an organization are up to date with the latest security patches and software updates. Patch compliance helps maintain security, stability, and performance by reducing vulnerabilities that could be exploited by cyber threats.
Azure Security Center helps monitor patch compliance through its compliance dashboard, which highlights any unpatched systems in your environment. For example, an IT team can use Azure Security Center to assess the patch status of virtual machines and provide recommendations to ensure they meet security standards and compliance requirements. In this video, you learned about the importance of regular updates and patching for maintaining secure applications in Azure. Staying ahead of security threats requires consistent action. By automating updates, enabling service updates, and tracking compliance, you can safeguard your systems and maintain trust in your applications.
When you're running a website or any asset in the cloud, you want to make sure that you're regularly checking to make sure that it's up to date and running efficiently and optimized as much as you can. In this screencast, we're going to demonstrate how to perform performance tuning and system optimization in Azure to maintain optimal performance. I've got this simple web app in Azure. It's a demo web app, so it's not getting a lot of traffic, just data that I've been sending to it and using. This web app will allow us to look at how we can use Azure Monitor and the data in Azure to make sure that our app is running the way we want it to. I'm on the overview section of the application page. The monitoring tab, even in overview, gives us some good data here. We can see how much data is coming in, how much data is going out, if there's any HTTP5X errors. We can also get a sense of the response time. Like these queries I was doing earlier took about 1.2 seconds, and how many requests have come in. This is pretty good information. We can actually add cards if we wanted to, and do more observations on some of the data about this website. I can go a little bit deeper by using the monitoring feature of this web app. I can click on metrics, and I can come in here and I can create a number of different metrics that I can use to evaluate my website. For example, I can look at CPU time in aggregate. I can see data in, data out. I can get a health check status, and it will tell me if there's anything specifically going wrong. And I can add a bunch of these cards to this metrics tab and get a sense of how my app is performing. Here's one that's giving me thread count. These features will allow me to gain a lot of visibility into how my app is performing. Obviously, the more traffic that is going to my app, the more people are using it, the more queries it's making against a database and all that. The more heavily it's used, the more metrics you'll see, and the more those metrics will be important. Now, suppose you're looking at these metrics and you decide, I need to be able to scale up. That means give it more horsepower, more memory, more CPU options, or scale out, which means I want to make sure that I can replicate my existing environment for demand peak times or whatever. In order to do that, I can look at my app service plan. And if I click on app service plan, I get a number of options for being able to scale up and scale out. I'm on the free plan. So the pricing plan is F1, and I have the instance count. I have 0 additional instances of this app. I only have the single instance running. Now, because it's a demo app, that doesn't matter very much. But if I want to increase my ability to support more users, I can scale up. If I'm noticing CPU usage is high, for example, or it's using a lot of memory, I can scale up and I get a number of different options. It also gives me the cost per hour and the cost per month, and that's per instance. And I can also see here under feature view whether or not this will auto scale. So as usage and traffic increases, will this automatically scale? In basic B1, that plan, I have to manually scale. I can scale, but I'll have to do it manually. Here I can scale based on rules. This is an elastic scaling, which is very nice. And then under these legacy plans, these are all rule-based as well. So I can say if CPU usage is over 75% for more than 2 minutes, I want to scale up. I want to give the instance more horsepower. Let's go back to this other option, the scale out option. This similarly will give me a lot of options for how I can scale out my instances and make this more robust under certain conditions. I can look at all the options here. I've got the auto scale option, the daily backup, staging plans, and it will give me options for how I want to organize my infrastructure so that I can make sure my app is always up and always working properly. Those are some options for not only monitoring how your app is doing on Azure, but also addressing problems with resources when you evaluate some of those metrics that we looked at earlier. Now we're going to shift gears a little bit and go to looking at how we can optimize our queries when we're working against an Azure database. I'm going to simulate this by working with a local MySQL database, but it works similarly if you're working with Azure. So I'm going to use Copilot to help me improve my query. I'm going to open up Copilot. I'm going to ask it to improve and optimize this query. I'm going to paste that in. It says the query works, but we can use joins explicitly, avoid correlated subqueries, and consider indexing.
Let's get into MySQL.
And we'll look at how these perform. I'll log in, and then I'll use my database called ShopDB. Now, the first thing I want to do is see how my original query performs. I'm going to paste that in, and this is the result it gets me. I'm looking for things like here it's this O means that it's scanning all the tables. This loose scan can be pretty inefficient, so you can see some differences there. Now I'm going to go back to Copilot, and I'm going to grab the new query. It already has the explain statement in it, so I'll go ahead and paste this in and run that, see if there's any differences. We still have our O here, which means it is scanning all the tables, but we got rid of that loose scan, which is going to be a little bit more efficient. And there's not a whole lot of other differences. Let's go back and try that second query and see if it's a little bit more optimized. And we'll go ahead and try that in MySQL and see if this works even better. Now we've got a little bit more information. This one ran 4 times to get through the query, but on large data sets, this might actually perform better. It might actually be a higher performing query overall. We can actually look at one other option that is even more optimized than these. I'm going to paste that in and run that. Now, this option only provides 2 rows back. It doesn't use this O, which means it's not scanning every table. It's very efficient because it's got an inner join, and it's only having to scan and query the tables that we need. This is probably going to be the most optimized, at least for this small table with not a lot of data in it. And you can see the differences here as we work with Copilot on trying to get some improved and more performant queries. The idea here is that as you're building out your infrastructure, as you're working on evaluating how well your applications are performing, you want to constantly be looking at those metrics on Azure, constantly be working with Copilot to see if there's areas that you can improve. Use these explain statements in SQL queries to see if you can get some better results. I'm running against a local MySQL database, but you can do the same types of queries against Azure databases. And always be looking to tune your performance and optimize your applications and database queries on Azure. As you've discovered, effective application monitoring and maintenance are essential for ensuring system reliability and performance. Proactively identifying issues, optimizing logs, and leveraging automation helps streamline operations and keeps applications running efficiently in a cloud environment. We began by examining the core principles of application monitoring, understanding its role in maintaining system performance, detecting potential issues, and ensuring the reliability of backend systems. Next, we dove into Azure Monitor, discovering how its advanced tools help track application performance, identify irregularities, and provide real-time insights to support proactive decision-making. Then we examined best practices for logging and log management, exploring effective techniques for collecting, structuring, and analyzing logs to diagnose issues and enhance system performance. After that, we explored how to automate routine maintenance tasks in Azure, leveraging automation tools to minimize manual effort, increase efficiency, and improve system stability. Finally, we identified effective strategies for sustaining application performance in Azure, focusing on proactive maintenance, security enhancements, and long-term optimization to ensure stability and reliability.
Mastering application monitoring and maintenance is crucial for ensuring long-term system stability and performance. Applying these strategies will help you proactively manage applications, minimize downtime, and optimize efficiency in a cloud environment. Welcome to Using Copilot for Automating Deployment Scripts and CI/CD Pipelines. This module explores how Microsoft Copilot enhances DevOps by automating deployment scripts and streamlining CI/CD pipelines. You'll learn how to improve efficiency, reduce errors, and optimize deployment workflows by leveraging AI-driven assistance. We will begin by identifying how Microsoft Copilot can assist in writing automated deployment scripts, leveraging AI-powered suggestions to streamline and optimize deployment processes. Next, we'll focus on developing CI/CD pipelines with Copilot, learning to generate efficient scripts that automate integration, testing, and deployment workflows with minimal manual effort. Then we will examine how Copilot can help debug and optimize deployment processes, identify errors, improve efficiency, and ensure smooth application rollouts. Finally, we will apply Copilot to automate and enhance DevOps workflows, integrating AI-driven solutions to improve collaboration, increase deployment speed, and optimize overall system performance. By the end of this module, you will have the skills to harness Microsoft Copilot for automating deployment scripts, optimizing CI/CD pipelines, and streamlining DevOps workflows. Let's get started. Software deployment involves more than just moving code from one environment to another. It involves ensuring consistency, speed, and reliability. By using automated processes in deployment, you can reduce manual errors, streamline updates, and ensure applications perform well across different environments. In this video, we will identify the core concepts and benefits of deployment automation using Microsoft Copilot. To begin, let's explore some deployment automation concepts, starting with Infrastructure as Code, or IAC. Infrastructure as Code is the practice of managing and provisioning computing infrastructure through machine-readable configuration files rather than manual processes. This allows for automation consistency and scalability in deploying and maintaining infrastructure across different environments. With Copilot, you can generate IAC scripts or files, validate configuration for accuracy, and identify potential issues. For example, instead of manually creating and configuring a virtual machine, you define its specifications, such as CPU, memory, and operating system, in a script using Copilot. The script can be executed repeatedly to create identical environments, reducing human error and ensuring reliability. Once the infrastructure is defined, it becomes crucial to keep systems consistent over time, which is where configuration management comes in. Configuration management is the process of automating system setup and ensuring uniform configurations across multiple environments. It helps automate deployments, track modifications, and prevent configuration drift using tools like Azure Automation. Copilot also supports this process by debugging configuration scripts, reducing errors, and maintaining consistent behavior across all environments. For example, if your app requires a specific version of a database, configuration management using Copilot will help ensure that every system is running the correct version. Another important deployment automation concept is automating how code updates are delivered through continuous deployment. Recall that continuous deployment automates the process of releasing new code to production as soon as it passes tests, enabling faster and more reliable updates. This ensures faster delivery of new features, bug fixes, and updates while maintaining stability and reliability. Copilot can assist by optimizing deployment pipelines, identifying potential issues, and ensuring smooth delivery process. For instance, after committing code, a Copilot optimized automation pipeline tests and deploys it without delays. Even with the help of automation, deployments can sometimes fail, making it essential to recover quickly. So it is important to have a rollback strategy in place. Rollback strategies are plans or processes for reverting a system application, or infrastructure to its previous stable state in case of failure or issues during an update, deployment, or change. These strategies ensure minimal downtime and data loss by rolling back code, configurations, or database changes to a known good version. Copilot enhances these processes by analyzing logs, identifying triggers for rollbacks, and recommending recovery strategies to ensure swift resolutions. For example, if a faulty update is deployed to a web application, a rollback strategy could quickly restore the previous stable version to prevent downtime. This ensures that users continue to have a functional experience while developers address the issue. In this video, you learned some core concepts and benefits of deployment automation using Microsoft Copilot. With Microsoft Copilot, you can automate deployment tasks like infrastructure setup, configuration management, deployment, and recovery, enabling more reliable and effective software delivery.
In this screencast, we're going to demonstrate how to generate, customize, and execute deployment scripts using Microsoft Copilot with Visual Studio Code or VS Code. I've got VS Code open, and I've got the Microsoft Copilot extension running. That's down here. And I've also installed the Microsoft Azure CLI, or command line interface, in the background. That's also running. And you can get that off the Microsoft Azure site or do a search for Microsoft Azure CLI, and you can get the installation package for that. Now that I have my environment set up, I can start to interact with Azure using Copilot as well as using the command line interface. In order to use Azure commands, it's just AZ, and I'm going to just check to make sure that I do have that installed and it's working. So I type AZ version, and it gives me the client version, the core version, this Azure CLI telemetry, which allows me to get data from Azure, and the extensions I have installed, which in this case I don't have any. But at least I know that Azure CLI is installed and it's running. Now I can use the CLI to actually log in to Azure. I'm going to say AZ login, and it logs me in, and now I'm able to continue. Once I'm logged in, now I can use Azure to do a number of different things. The first thing I want to do is create a deployment file. I'm going to call this deploy.ps1. This is a PowerShell script file. Now I'm going to use Copilot to help me write this script. The first thing I'm going to do is put in a comment here at the top, and I'm just going to say write a PowerShell script to deploy a node.js app to Azure. I can invoke Copilot by going to Copilot. I'm going to use the fix command. Copilot's going to look at that comment, and it's going to evaluate what I want it to do. It says the current script is just a comment, does not contain any code. You can write a PowerShell script that uses Azure CLI command. That's exactly what we want. So it's actually generated the file that I asked it to generate here. And I'm going to accept the changes, and now my file is populated. I got rid of the question that I had asked it, and then it actually created this new file for me. You'll notice it does the AZ login command, and then it sets the Azure subscription. I have to put in my subscription ID. I have to specify the resource group name that I want, and then it will actually create that resource group. It'll ask me for an app service plan name. I can put that name in, then it'll create the app service plan. It defaults to the free SKU, which is good because I can always change that later. Then it asks me to create a web app. It's going to ask for a name. What web app name do I want? Here it's just my Node.js app and then a random variable. It actually has all the code to deploy that Node.js app to Azure. All these commands will run. It will actually create a service plan. It will create a resource group. It will create a web app. And then it will actually deploy all that to Azure, which is all done from the script. And of course, I can modify the script in any way that I'd like to have it do other things, whatever I'd like it to do. Now, to deploy this, I simply have to write /deploy ps1 from the command line. Because I'm in PowerShell, I can use PowerShell commands, and that's the PowerShell command for deploying the script. All of that work can be done right from the command line. I'm doing it in Visual Studio, but I can also create this PS1 file outside of Visual Studio Code and just use the terminal to do that. I'm not going to run this command at this point because I would need to fill in all that information, but I'm going to show you the command that you can use to get data on whether your application is running. You can use this AZ web app show, and then you can put in all your app name and resource information there, and it will show you that app running on Azure. The Azure CLI gives you a lot of power to be able to configure and deploy apps and write to Azure without having to use the portal. And you also have the ability to use Copilot to help you generate these scripts. I can go into any of these lines and ask Copilot to help me modify them and change them in any way that I need to. In this lab, we're going to implement an automated deployment process using Copilot-generated scripts within Visual Studio Code or VS Code. Let's assume that we have an app here that we want to deploy to Azure. We're going to use the Azure Command Line Interface CLI tools to do this deployment. And I've got a deploy.sh file, which is a shell file that I'm going to use to run my deployment commands. And so I'm going to use the AZ commands to do this in this shell file. In step one, we're going to set up the Visual Code and the Visual Studio environments that we can use the Azure Command Line Interface. The first set of commands that we're going to use here are, first of all, opening the application in code, so code dot. And then we're going to use the AZ version command to get the version of our Azure CLI. And that's mainly just to verify that we have the CLI installed. And then we're going to log into Azure using AZ login. Now, because we're doing this from a shell file, we would eventually want to add some error trapping to this so that if AZ version returns an error, we can trap for that and then not move forward. But for this lab, we're just showing how these commands are run and how you can run them from a shell file. You can also run these obviously from the terminal individually and get some feedback. In step two, we're going to generate our initial deployment script with Copilot. And for this, I'm going to paste in some code with comments. This code is already complete, but we can use Copilot to generate this code if we needed to. I'm going to go ahead and paste this in. You'll see we have Copilot prompts here, and these are in comments. I have Copilot for VS Code installed, and I can interact with Copilot here. If I were doing this from scratch, I would use these comments to inform Copilot about what I want to do next. For this lab, we'll assume that Copilot is generating this code for us, but we want to see what commands we want to use for these specific Azure CLI prompts. The first one we want to look at here is the prompt that we're going to give to Copilot, that we wanted to write a PowerShell script to deploy a Node.js app to Azure. And Copilot will use that prompt in order to know how to fill out the rest of the items here. And then we're going to use the AZ group create command to create a resource group. Here we're calling it Contoso group, which is a fake name. In a real world application, you'd want to put your resource group that you want to use there, the name that you want to use in that slot. And then the next thing we're going to do is create a web app. We'll use the command AZ web app create. We're going to pass in our name of our web app. Again, Contoso web app is a pseudo name just for the purpose of the lab. And then we're going to pass in our resource group, Contoso group, and then whatever app service plan that we have set. We've got that as Contoso plan here. Step two is about generating the Azure resources that we need to be able to publish our app. And now we're going to customize the script a little bit with some variables. This will work, but we want to use variables because as we build out this script, we don't want to keep having to write out Contoso group every time we want to create an Azure resource or things like that. We can ask Copilot to generate some variables for us. Let's start at the top. We can use this prompt here, set environment variables, export app name Contoso web app. And if I hit enter, you'll notice that Copilot is working for me in the background here.
And it's also saying that we should use the resource group, Contoso group. We can even use export location if we wanted to. But here we're saying we want the resource group variable to be set to Contoso group. And then we can go into our AZ commands and change out those specific items for the variables that we just set. If I were doing this in a real app, I would set this up as this. And then that allows us to be able to use those variables. You actually need to put a $sign in front of this so it knows to use the variable. In step 4, we're going to apply a free tier eligible VM size for our VM. Let's use another VM create and let's do -- size and see if Copilot will give us some help. It gives me a bunch of options. I can accept the word by holding down Control and doing the right arrow. And now I have the standard B1S as the size. I just put in the -size and Copilot was able to anticipate that there's another number of options that I can provide there. By using Control right arrow, I was able to select that size and fill in the rest of that item. Copilot actually helped me complete this line of code by just me beginning to type what I needed and then Copilot anticipating the rest. That's how you can use Copilot to debug and optimize your deployment scripts. And obviously there's a lot more we could add to this script if we wanted to, and Copilot could actually help us with some other items as we get into building out this. You can open up ports and do a number of other things. Modern software development relies on speed, consistency, and reliability to deliver high-quality product to users. Automation scripts are essential to achieving these goals by reducing manual work and ensuring repeatable processes. Tools like Microsoft Copilot take automation to the next level, simplifying complex workflows and making them more efficient. In this lesson, we will describe the role of automation scripts in continuous integration, continuous deployment pipelines, and how Copilot enhances this process. To begin, let's review some CI/CD automation concepts, starting with build automation. Build automation refers to automatically compiling, testing, and preparing code for deployment whenever changes are made. It ensures consistent, error-free builds, integrates testing, and enables faster, more reliable software releases. Copilot aids in building automation by providing AI-driven code suggestions for building, testing, and deploying applications in CI/CD pipelines. For example, Copilot can automatically suggest YAML configurations for setting up CI/CD pipelines in Azure DevOps, simplifying the build and deployment process. It can also help write scripts for automated testing, ensuring every change is validated before deployment. Once the code is built, it's crucial to verify that it functions correctly, which is where test automation makes this process faster and more reliable by running test suites automatically. Test automation refers to the practice of automatically running tests such as unit tests, integration tests, and end-to-end tests whenever code is committed or deployed. This ensures that any changes to the code base are immediately validated, helping to catch bugs early and maintain software quality through the development process. Copilot assists with test automation in CI/CD pipelines by suggesting code for writing test cases, generating test scripts, and integrating them into the pipeline. For example, in an online payment system, automated tests can verify that the checkout process functions correctly after updates, preventing issues from impacting users. Copilot can assist by suggesting test scripts for scenarios like payment validation or checkout flow, helping ensure that these tests are automatically executed by the CI/CD pipeline with each code change. Once testing is complete, deployment automation releases your apps to users. Deployment automation refers to the process of automatically deploying code to various environments, such as development, staging, and production, as part of the CI/CD pipeline. This ensures that software updates are released quickly, consistently, and reliably, with minimal manual intervention. Copilot assists with deployment automation by suggesting configuration files, scripts, and code for automating the deployment process across different environments. For example, weather apps rely on deployment automation to update their backend quickly and consistently, ensuring users always have the latest features without downtime. Copilot can assist by suggesting deployment pipeline configurations and scripts, automating the deployment process, and ensuring that updates are pushed seamlessly across environments without manual intervention. To ensure everything works together seamlessly, automation tasks are organized into pipelines, and pipeline configuration defines how these tasks flow, ensuring that they happen in the correct order every time. Pipeline configuration refers to setting up and defining the steps or stages in a CI/CD pipeline. These pipelines automate the process of building, testing, and deploying software, often using configuration files like YAML. It specifies how code is built, tested, and deployed through the pipeline, often using configuration files to outline each stage, the order in which they run, and any dependencies or conditions for execution. Copilot helps with pipeline configuration by automatically suggesting and generating the necessary code for setting up CI/CD pipelines. For example, a pipeline configuration might specify that after the code is built, tests are run, and then the application is deployed. Copilot can help by automatically suggesting YAML or JSON snippets for each stage of the pipeline, ensuring a seamless and efficient workflow, and allowing developers to quickly set up the build, test, and deploy processes with minimal manual configuration. Automation scripts are transforming software development by making processes faster, more reliable, and less error-prone. With tools like Copilot, developers can take automation to the next level, streamlining workflows and empowering teams to deliver better software more efficiently.
Using generative AI tools like Copilot, don't stop at just writing code. You can also use Copilot to help you generate automation scripts for your continuous integration, continuous deployment pipeline. In this screencast, we're going to demonstrate how to generate, customize, and implement CI/CD pipeline scripts using Microsoft Copilot within Visual Studio Code. I have a ci.yaml file open here in Visual Studio Code. I'm going to use this as a GitHub Actions script. I've just got one comment in here, and I put the comment in so that when I interact with Copilot, Copilot has some context for what I'm trying to do. Now I've got Copilot integrated into VS Code. I could also use Copilot on the web or on the app. This is the Windows app. And I can use any of these as I need to interact with Copilot. But I'm going to use this tool here. I'm just going to go to the chat window. And so that's open on the side now. And Copilot has some context for my file. I have ci.yaml as the current file. Copilot can actually interact with the file that I have open in Visual Studio Code. Now I'm going to ask it to generate GitHub's Action YAML pipeline. It's going to see the comment that I have, but I'm also going to prompt it with very specific things that I want it to do. I'll go ahead and put that prompt in the application. And I'll send that over. You can also see here that I can use different models. This one's using GPT-4o, and I'll just go ahead and use that for now. I can also have it operate as an agent. I'm going to change this to edit, so it will actually edit the file when I ask it to. I'm going to go ahead and send this over to Copilot. It's going to generate the edits that I need based on the prompt that I sent it. Once Copilot generates that code, we can obviously interact with the code, change it, and continue to work with Copilot to make those changes. So Copilot's generating the code. Once it's generated this code for me, I can review it. I can go through and see if this is what I want. It looks generally right. Obviously, we wouldn't want to go through this in more detail, but it looks generally correct. So I'm going to select Keep. And sometimes it will give you multiple changes that you can scroll through. You can say, I don't want those changes, I want to undo that, but I'm going to keep these. And once I've selected that button, it puts that code right into my file for me. And now I'm ready to go. I can edit this as I need to. I can make changes as I need to. I can review the steps for my deployment. And I can also then go ahead and push this directly to GitHub so that I can then use it as a builder. For example, if I didn't have a GitHub repository in this project, I can create a GitHub repository. For example, commands like these I can initialize my GitHub repository. I would then add the file or whatever files I have in my project, commit the pipeline file to my repository, add a remote origin. So this is just a fake repository, but if I had one that already existed, I could put that repository there, or I can create a new one, and then I could push these changes up to GitHub. I'm not going to do that for the screencast, but these are the commands you could use so that you can actually interact with GitHub and push those files. All right, let me close the terminal window. Now, the next thing I want to do is interact with Copilot to optimize this file. I've got a simple prompt here, and I'm going to keep this window open, and I'm also going to keep it in edit mode so that as Copilot suggests changes, I can add them right to my code. I'm going to prompt it with suggesting optimizations for these actions, such as caching, parallel execution, or conditional deployment. This deployment script is fairly basic. It has a build job, it has a deploy job, and some very basic steps, but we want to optimize this and make it a little bit better. So let's go ahead and prompt Copilot to see what suggestions Copilot provides. Generating the edits right in the file, it goes through and looks at the code. It's adding this block, so this is new, and I can accept that change if I'd like to. And right at this point now, I can go through each change individually. I can also navigate it through this interface. That's the first one. Obviously, that's the second one, and then that's the third one. So suggesting 3 changes, I can keep them all, or I can go through and I can accept them individually. So let's accept them individually. Now I've got this new block here, which improves the overall deployment script. This one I'm going to also accept. That's a variable that it's adding. And then this final one is a conditional statement. If certain conditions are true, then the steps will run. I've worked with Copilot on creating the original file, and now I'm working with Copilot on improving it and doing things that I need to make the script even better. I would then go ahead and push that to GitHub. That new script then would run on certain conditions based on what I put in this code. This is a way that you can use Copilot and tools like Copilot to continually improve your workflow. You can use Copilot obviously to generate the code that you're writing, but then also when you get to the deployment stage, Copilot can help you create those scripts so that you can have a really solid CI/CD pipeline. In this lab, we're going to develop and implement a CI/CD pipeline using Copilot generated scripts within Visual Studio Code or VS Code. To begin, we're going to essentially set up our directory and move into that directory so we can begin developing this app. The scenario is that we join this new tech company called Technova, and we're going to help them automate their deployments. The first thing we'll do here is just generate that folder that we're going to use called Technova Deploy. And then we're going to change directory using the cd command and move into the Technova Deploy directory that we just created. Now I've got this all set up already in the background, so we don't really need to do that. But if you were beginning a new project, this is the first step that you'd want to take. The next thing we're going to do is generate an initial pipeline script with Copilot. We can use Copilot integrated into Visual Studio Code like I have here. I can ask Copilot to do something, or we can use our standalone Copilot, which I also have here. Let's suppose that we prompted Copilot to generate a deployment script that will allow us to deploy a Node.js application to GitHub. The first thing we're going to do is look at the code that Copilot gives us back, and we're going to evaluate it to make sure that it has the things we want. If we have a trigger up here at the top on push branches, and we want to verify that that's the main branch that we're concerned about. If that's not what we want, we can certainly change that. Copilot would generally give us the main branch because that's fairly typical. And then we have our jobs, and our build job runs on Ubuntu latest, and then we have the individual steps where we first check out the code, which makes the code available to the workflow. And then we're going to set up Node.js. We're going to use that action/setup-node command to make sure that Node is running in our environment as we run the workflow. And we want to do that with Node version 16. Now,
If Copilot returned all this code for us, we'd want to evaluate that these are the actual things that we want. If we didn't specify in our prompt, for example, that we want a newer version of Node, and it gives us 16, we'd have to go ahead and change that. But we can also specify in the prompt so that Copilot gives us what we want. Then we have our dependencies that we're going to install, and we're going to use npm install. Copilot is trying to anticipate what I want to do next. It's giving me another set of options here, and I can continue to use Copilot to build out my test steps. I actually don't want to do this, so I would prompt Copilot with a different query. And let's suppose that I said I wanted to build the project and then I wanted to test the project using Node commands. Copilot might return something like this that we can use to, again, evaluate and fill out. In step 3, we're adding our build and test steps, and we're going to use the command npm run build and the command npm test to implement those 2 steps. And of course, we give our steps names. The first one is build project, and then the second one is run tests. Now for step 4, we're going to commit and configure the pipeline into our Git repository. So we assume that we have a Git repository set up, and we're going to go ahead and commit the changes. I'm going to open up my terminal, and I'll clear out this so we can see it more clearly. I'm going to use the git add command, and I'm going to use GitHub/workflows, which is the location of where I have my ci.yaml file. And I'm essentially just telling GitHub, add it to the repository as an item, stage it, and then I'm going to commit it using this comment, add initial CI/CD pipeline. So now we're putting it into our local Git repository. And when we push that to GitHub, then that YAML file will operate and work on GitHub as we push code to the repository, which is what we're going to do in step 5. We're going to push changes and trigger the pipeline. The next command would be that push origin command. So we're going to say whatever's in the local GitHub repository now, push to the origin, which is the remote repository, and we want to push to the main branch. So that will push that YAML file to the main branch. Now, anytime we make changes to our project, and we use these same commands, we commit to our local repository and then push to the main branch, this workflow will run each time. And that's how we get the workflow operating properly. The Copilot may give us is to add caching to the pipeline so that we can reuse previously installed dependencies instead of relying on them each time. So what we're going to do then is add some code that Copilot gives to us so that we can better reuse resources. And I'm going to do that here. And Copilot would tell us exactly where to put that. And you can see that we've got the cache dependencies item here. And we're going to use the GitHub native cache to do that. And then we give it some parameters. We're going to give it the path here first. We're going to give it the key that we want to be able to use for this, and then any restore keys that we need. So we can use these parameters, key and restore keys, to better improve the cache and to actually work with the cache. By using this cache dependencies, we've improved our workflow, and we can continue to ask Copilot if there's other ways and other things that we can do here to optimize our workflow. Caching is just one of the things that Copilot will give us. So these are ways that you can, first of all, create your pipeline, but also use Copilot to set up the initial pipeline and then improve it as you go so that you can better optimize it for your workflows.
Debugging deployment scripts isn't just about fixing errors, it's about ensuring seamless and efficient deployments. Copilot simplifies this process by helping developers identify common issues such as syntax errors, missing dependencies, and performance bottlenecks before they cause failures. In this video, we will explain how Copilot assists in debugging deployment scripts by identifying errors and inefficiencies. To begin, let's explore some key concepts for debugging with Copilot, starting with error detection. Error detection is the process of identifying and recognizing faults
inconsistencies, or issues in data transmission, software execution, or system operations. Error detection helps maintain reliability and performance in applications by enabling corrective actions before errors cause significant failures. Copilot can employ error detection techniques to identify problems in deployment scripts, such as syntax and logical errors, highlighting the issues and providing suggestions for fixing them quickly. For example, if you forget to declare a variable before using it, Copilot highlights the issue and suggests where to add the declaration. This immediate feedback helps you resolve small mistakes in your scripts quickly, allowing you to focus on more complex problems. After using Copilot to help address script errors, another key concept for debugging is dependency management. Dependency management is the process of handling external libraries, frameworks, and packages that a software project relies on to function correctly. It ensures that correct versions are installed, updated, and compatible, preventing conflicts and maintaining application stability. Missing or outdated libraries and scripts can cause deployment failures, and Copilot can help manage dependencies by suggesting the correct versions of libraries and frameworks needed for your project. For example, Copilot can analyze your script and recommend the correct command to fix issues like installing a missing library or updating an outdated one. When working on an application with multiple developers, you may also come across version control conflicts in your scripts that Copilot can help you resolve. Version control conflicts occur when multiple contributors make conflicting changes to the same file or code base, preventing automatic merging. These conflicts must be resolved manually by reviewing the differences and determining the correct version to keep. However, Copilot simplifies this process by identifying conflicting changes and suggesting merge strategies. For example, when two developers edit the same section of code in a shared repository, a version control conflict may arise requiring manual resolution. Copilot can assist by analyzing the conflicting changes, suggesting possible resolutions, and streamlining the merge process. Finally, even when all other bugs have been resolved, inefficiencies in your script can slow down the deployment process, which is where Copilot's suggestions for performance monitoring can be helpful. Performance monitoring is the process of tracking, analyzing, and optimizing the performance of application systems or networks to ensure they operate efficiently and reliably. It helps identify bottlenecks, detect anomalies, and improve overall user experience by providing real-time insights and historical data on resource usage, response times, and errors. Copilot helps improve script efficiency by identifying redundant operations and suggesting optimizations, such as restructuring loops or reducing unnecessary computations. For example, if a script contains a loop that processes the same files multiple times, Copilot may recommend restructuring the code to perform the task in a single step. These optimizations can make your deployments faster and more reliable. In this video, you learned about how Copilot assists in debugging deployment scripts by identifying errors and inefficiencies. Copilot empowers developers to debug deployment scripts with confidence. By simplifying and automating tasks, Copilot ensures smoother, more reliable deployments while saving developers time and effort.
You can use Microsoft Copilot to help you debug code. You can also use Copilot to help you debug deployment scripts. Suppose you were given a deployment script from another engineer and you wanted to have it reviewed or fix some bugs. You can invoke Copilot and have it work with you to make those changes. In this screencast, we're going to demonstrate the process of debugging a deployment script using Copilot within Visual Studio Code. I have a deployment PowerShell script here, a deploy.ps1 file. I've intentionally introduced some bugs, some code problems. This script won't run properly. This is a script that uses the Azure CLI, the command line interface, which I've installed separately. It uses these AZ commands, so I want to create a resource group. I then want to create a virtual machine, so AZVM create, and then I want to configure my resource group. But it has some problems. We're going to use Copilot integrated into Visual Studio Code. I can also use the standalone version or the web version if I wanted to, but I've got Copilot integrated into VS Code, so I'm just going to use that interface to work with this. I'm going to open the chat, A couple of things here. I've got a Copilot instance open in the sidebar and my file. Copilot's aware of the file that I'm working with. It says here it's deploy.csps1. I'm also in edit mode, so I can choose to ask it a question. I can have it edit my file, or I can actually have it do things beyond edit. So I'm going to keep it in edit mode, which means that when Copilot suggests a change, it's going to give Copilot the ability to modify the file directly. And that way I don't have to do any copying and pasting. I'm also using the OpenAI GPT-4 model to interact with this version of Copilot. The first thing I want to do is ask Copilot to modify this file. I'm going to ask it to detect errors in the script and make changes so the script runs. It's just a very simple prompt, but I'm asking it to go through and then actually do the edits for me. Go ahead and send that prompt over. It's generating the edits that I need. And notice that it gives me right in line the edits that I need to be able to make. I can scroll through these edits. All it's doing right now is it's just modifying the 2 lines here. The AZ group create line is missing a location. Copilot suggesting that we add a location. This is missing a username and the generate SSH keys flag. And it's suggesting that we add both of those as well. So I'm going to choose to keep those. And now my file is operational. I can actually use it. Now here, obviously, I might want to change some of the names. Copilot doesn't know what I want to name my resource group, so calling it my resource group probably is not what I want to do. I also would have to add my username here. Azure user isn't an active name. So I would have to go through and personalize this. Copilot doesn't have access to that information. I could provide it, but I would probably just hand edit this so that I can include that type of information. Let's suppose I want to take this file and I want to refactor it a little bit, and I want to edit it and have Copilot help me refactor this script for reusability. Because right now, every time I reference resource group, if I wanted to continue to build out this script, the resource group is hard-coded and I'd have to put it everywhere. So if I want to be able to use, for example, variables, or just be able to have a little bit more flexibility in my script, this isn't set up to do that. So I'm going to go ahead and put this prompt in. Can you help me refactor this script for reusability? And let's see what Copilot comes back with in terms of edits. We'll send that over to Copilot. It's seen my prompts and it's going to go through and help me modify this. It's suggesting that this goes away. So there's one big edit. It's going to remove this section and it's going to add this new green section. It's suggesting that we remove this, and we're going to obviously move that down here. But what it's suggesting is that we create variables. There's going to be this $ resource group name, and then we put the resource group in. The location, since we might want to reuse that continually, is also in a variable, and the same with the VM name. All these personalized things here, we can change and put into variables, and then Copilot's suggesting that we then use those variables throughout the script. That seems like a really good idea. I can either accept that change here, or I can go down here and say keep, so I'm going to keep that. Now we've got a better structure for this script. And Copilot's also added comments, so what's happening at each stage. If I want to continue to build the script out, anytime I need to reference my resource group, I've got that in a variable and I just need to change it in one place. I change it once here at the top and then it can be reused throughout the script. I can continue to do this with Copilot and continue to refactor and make the script even more robust, particularly as it gets more complicated. Tools like Copilot are really helpful for not only developing original code, but for helping debug code that you may get from other engineers or from another source somewhere on the internet, and also helping you to improve your code so that it's optimized and much easier to read and edit. In this lab, we're going to apply debugging techniques using Copilot within VS Code to optimize deployment processes. In step one, the first thing we want to do is initialize the Git repository in our local folder here so that we can make sure that we track our changes. I'm going to open up my terminal and use git init to set up the repository.
if we were to run this, that would set up a repository in the folder, and now we can track our changes. In step 2, we're going to use Copilot to identify a missing parameter within our .ps1 file. So we've got this deployment file. It's written as a PowerShell script. We're going to use Copilot to help us identify what's missing. So let's suppose we had a command like this, and this was given to us by someone else, and we know it's not running. There's something wrong with it. I get prompted Control-I to continue with Copilot. Copilot can help us actually improve this and figure out what the issue is. Let's just suppose we take this and we ask Copilot to help us. So I'm going to go into my Copilot here and say something is missing from this command. Can you help me fix it? It tells me that the issue is that the AZ command is missing the configure keyword, and it actually provides that keyword there. If I click accept, it will give me the configure keyword. And I can use Copilot in this way to actually update my code for me, or I can use my standalone Copilot and ask it the question. Put the code into the prompt and ask it to help me figure it out. So by adding configure, now we've got our line that is complete. Now, the next thing we were going to do here is secure a VM deployment. So we're going to actually add a VM deployment by enabling SSH-based authentication. We've got this line, and I can paste this in, prompt Copilot, and ask Copilot to help us improve this. Copilot's already anticipating what I might want to do here. The next item is generate SSH keys, because it knows that's a typical flag or key for this VM create command. I can actually tab and have it create that for me, or I can have it just give me a portion of that. Now for this lab, we only care about the keys. Copilot suggested a bunch of other things, but I'm not going to use those. I'm just going to use the generate SSH keys that Copilot gave me because that's what I care about. Copilot will give me a bunch of other things if I need it, or I can just accept the generate SSH keys. In step 4, we're going to apply a free tier eligible VM size for our VM. Let's use another VM create, and let's do -- size and see if Copilot will give us some help. It gives me a bunch of options. I can accept the word by holding down Control and doing the right arrow. And now I have the standard B1S as the size. I just put in the -size, and Copilot was able to anticipate that there's another number of options that I can provide there. By using Control right arrow, I was able to select that size and fill in the rest of that item. Copilot actually helped me complete this line of code by just me beginning to type what I needed and then Copilot anticipating the rest. That's how you can use Copilot to debug and optimize your deployment scripts. And obviously there's a lot more we could add to the script if we wanted to, and Copilot could actually help us with some other items as we get into building out this. You can open up ports and do a number of other things.
DevOps automation has transformed how teams develop and manage software, minimizing errors and accelerating deployments. GitHub Copilot takes this further by assisting with complex DevOps tasks, enabling developers to focus on innovation rather than repetitive processes. In this video, we'll describe how Copilot assists in automating DevOps workflows, improving operational efficiency. To begin, let's explore some DevOps automation concepts, starting with continuous integration, or CI. Recall that continuous integration is the practice of automatically merging and testing code changes frequently to ensure stability and avoid integration issues. Copilot enhances productivity by integrating with development tools to automate code reviews, optimize testing, and streamline continuous integration and deployment processes. For instance, a retail company handling online transactions cannot afford broken code in its checkout systems. With Copilot assisting in writing test cases and improving code quality, CI tools can automatically test and merge new code changes,
reducing risks, and ensuring stable updates. Once code is merged successfully, the next step is deploying it to production, which is where continuous deployment, or CD, comes in. Recall that continuous deployment is a software development practice where code changes that pass automated tests are automatically deployed to production without manual intervention. Copilot assists with continuous deployment by generating deployment scripts, automating workflows, and reducing errors in CD pipelines, ensuring smoother and more reliable software releases. For example, a developer may need to continuously deploy code that integrates with code from other developers in a complex environment. Copilot can help the team account for all the variables that could cause problems or introduce errors, and create CD scripts and workflows that reduce risks and minimize issues. Along with deploying code, managing cloud infrastructure is also essential and is a key process developers can automate to make DevOps smoother. In the context of DevOps, infrastructure automation refers to the use of tools and scripts to automatically manage and provision IT infrastructure, such as servers, networks, databases, and storage. It eliminates the need for manual configuration and management, ensuring that environments are consistent, scalable, and easily reproducible. Copilot assists with infrastructure automation by suggesting code for defining and managing infrastructure as code, or IAC, allowing developers to quickly set up, configure, and update environments. For example, imagine a startup launching a web app that suddenly experiences a surge in traffic. If their servers aren't prepared for increased demand, the site could crash. With Copilot, the engineer can quickly generate infrastructure automation code to automatically scale resources, saving valuable time and ensuring the site remains operational under heavy traffic. Once infrastructure is automated and deployed, maintaining system performance through monitoring this implemented automation becomes the next challenge. In the context of DevOps, monitoring automation refers to the use of automated tools and processes to continually track the performance, availability, and health of systems, applications, and infrastructure. It enables real-time detection of issues like downtime, performance degradation, or security breaches, and can trigger automated responses such as alerts, scaling, or even self-healing actions. Copilot assists with monitoring automation by generating code for setting up monitoring tools, automating alert configurations, and helping developers quickly identify and respond to system issues. A video streaming service, for example, could experience slowdowns during peak hours. If engineers manually check logs, they might not detect issues until users complain. With Copilot assisting in setting up automation monitoring and alerts, teams can proactively address performance drops before they impact users. In this video, you learned how Copilot assists in automating DevOps workflows, improving operational efficiency. Copilot enhances this automation by reducing manual effort and increasing accuracy, allowing developers to focus on what truly matters, delivering reliable, high-quality software.
Tools like Microsoft Copilot are fantastic for helping you generate and improve your actual code, but they're also really powerful for helping you generate automation scripts that you can have a really solid continuous integration, continuous deployment pipeline. In this screencast, we're going to demonstrate how to automate DevOps workflows using Copilot generated scripts in Visual Studio Code. Suppose I have a Node.js app and we want to build a CI/CD pipeline, DevOps workflow pipeline using Copilot. I've got 3 files open here in my project, infrastructure.shell.sh, a YAML file for my GitHub pipeline, and then a PowerShell script that I can use to monitor my DevOps workflows. We're going to use Copilot to help us generate each of these files. And then, of course, we could push these to GitHub as we need to and use these actually on our project. The first thing I want to do is use this infrastructure.sh file to help me generate some Azure resources for my project. So we can actually start from the very beginning. We don't have to have these Azure resources set up. We can use this infrastructure.sh file, the shell file, to help us generate these resources. I'm going to open Copilot.
I could use Copilot on the web. I can also use Copilot, this desktop version, but I've got Copilot integrated into my Visual Studio Code environment. So I'm just going to go ahead and use that. I'm going to open the chat here. I'm in edit mode. I can set that mode here, which means I'm just not going to ask a question and get a response back that I would then have to copy and paste. Copilot is actually aware of the file that I'm working in. It's infrastructure.sh. And so it's aware of my context. And then as it provides the information that I need, it can actually add that to the file. So I don't have to actually copy and paste. I can see the edits in line and then accept them or not. So I'm going to ask it to write a script to create an Azure resource group, an app service plan, and a web app. It's going to provide me with all three of those things. So we'll go ahead and send that to Copilot. It's noticing the file that I want to do this in, and it actually made all those changes for me. It's created some variables for the resource group name, the location, the app service plan, and the name of the app. And then it's created the scripts. This is using the AZ command, which is the Azure command line interface, to do all this work. Obviously, that assumes that's installed in the background. If it isn't installed, I can ask Copilot for instructions on how I get that command line interface installed. But it's provided me with this code. Now notice it's not a part of my file yet. I have to choose to keep or undo what Copilot has given me. I'm going to choose to keep it because it looks like it's generally right. I'll go ahead and cancel that. But now I've got that code in my infrastructure.sh file. And now I can go ahead and edit it as I need to. If I want to change the resource group name or the web app name, obviously I would want to be able to do all those things here. I've got the start of a shell script that will create all of my Azure resources. Now suppose I want to go over to the YAML file and have Copilot help me create this pipeline script. So I can go over to CI/CD pipeline.yaml and start working with Copilot to get this script generated. I've got some information here in the Copilot sidebar. It automatically changed to CI/CD pipeline, still stays in edit mode, but it notices the context. As I switch between files, Copilot kind of works along with me and has changed that file as well. I can now work with this new file right in Copilot without having to tell it that I've changed context. I'm going to give it a quick prompt, create a GitHub Actions pipeline to deploy this node.js file to Azure Web Apps. Go ahead and prompt Copilot and it will work just like it did on the infrastructure.sh file, but now it knows that I want something different. I'm working with a YAML file, and so it's given me specific information so that I can actually build this DevOps workflow right in my YAML file. And it gives me the appropriate code. If I had told it the names that I'd use for my web app, it would be able to plug those in as well. My workflow might be to create this file first, get all the names that I want to use, and then let Copilot know what those names are, or ask it to reference the infrastructure.sh file for the individual names that I want to be able to use. So I'm going to go ahead and keep this for now, and then I can go ahead, as I did with the infrastructure.sh file, and make changes as I need to. Now, the final file we're going to work with is this monitoring setup.ps1. We're going to use Copilot again to help us create this file. Again, I'll switch. Copilot switches with me. I'll prompt Copilot to create a PowerShell script to add a CPU alert rule for an Azure web app. And again, we're going to work with the same web app. If I have the name set, it would just pull through. We can use Copilot to make these initial edits and evaluate the work that it's done here. I've got a resource group name and a web app name. Those could be pulled through from infrastructure. And then it's created this alert rule on Azure using that AZ command again. We're working with AZ and shell script, and we're also working with the AZ command in the PowerShell script. We can use the CLI for both of these. I'll go ahead and keep this as well. And now we have all three files just to get our DevOps pipeline and workflow going. We've got all these set up now. We've got the initial code that we can use, and we can go through and edit each of these files and work with Copilot as we make those edits. We can ask Copilot to help us improve the efficiency of these scripts. We can have Copilot improve our pipeline YAML file to make our deployment easier, and so on. So by keeping Copilot in that sidebar,
switching between the files that we need, we can continue to work with Copilot to improve and expand our DevOps workflow.
In this lab, we're going to apply Copilot to automate and optimize a complete DevOps workflow in a real-world scenario. So I've got Visual Studio Code open here, and I've got a couple of files created in my project, a deploy.sh, which is a shell file that we can run independently, and a ci.yaml file, which we're going to use for our workflow. So in step one, the first thing we're going to do is initialize our DevOps project. So we're going to run a few commands here to get the project set up and ready to go. Paste this code in. We can run this off from the command line, but we're going to run this in our shell script. Create our folder, our directory called e-commerce-devops, and then switch to that folder so that all the commands that we're running subsequently will be run from that directory. And then we're going to use the init command git.init to initialize a repository. Once we've done that, then we can log into our Azure account using AZ login. When that command is run, there's typically a UI that will pop up asking for username and password, and then you can log into your Azure account. Now I've got the Git CLI installed in the background and the Azure CLI installed in the background, and you can get those from the Git website and the Azure developer website so that you can use those tools as you interact with Azure through the command line. In step two, we're going to generate an infrastructure setup script. Because we're in a lab environment, I've already got this created, but in a real world, we could ask Copilot to help us generate this. So, for example, you might prompt Copilot with a prompt that says something like, I want to create a shell script that provisions an Azure resource group, an app service plan, and a web app. Copilot would come back with some code for you that you can paste in. We're going to use this code for our lab. This code's already been written, but Copilot could generate that. You can use Copilot integrated into Visual Studio Code. Either open a chat window or an inline chat, or you can use Copilot on the web as a separate application. First thing we've done is set up some variables that we'll use throughout our script so that we don't have to keep typing those names over and over again. So we've got resource group, location, the name of the app service plan, and the web app name. The first command is using AZ group create. So the create verb will create our resource group for us in the location that we've specified here, East US. And then we're going to use AZ app service plan. So this will create that app service plan for us. It'll use the resource group that we created in the first step, and we're going to set that to a Linux platform. And then the final item is to use AZ web app create. So this will actually create our web app. Again, that create verb like we did with the resource group. We're going to use the create verb with web app this time, and we're going to use the resource group and app service plan that we created in the first two steps. Use our web app name, which we defined up here, e-commerce-app, and we're saying that the runtime that we want is Node for this project. Okay, in step three, we're going to create our CI/CD pipeline script, and we would use Copilot here to help us build that script out. We're going to switch over to our ci.yaml file, but Copilot can have the context of what we've already asked it to do. And we might prompt it with something like scaffold a GitHub Actions pipeline that builds and deploys the app to Azure. It's got the context and all the names from this file, so we can use that prompt to build out this file. So for our lab environment, we're going to go ahead and use this script, assuming that Copilot generated it for us. We've got a number of things that are happening here. We first of all just give it a name. We tell it an event, something to look for so that these jobs will run that we define here. And we want it to run on anytime there's a push to the main branch. That main is what we define for the branches that the workflow will look for. When anything is pushed to that branch, then it will run. Under jobs, we've got our build and deploy job, which runs on Ubuntu. And then here's the steps for that build and deploy job. First thing we're going to do is use the actions/checkout action, which makes the code available to the workflow. So we have to do that checkout first to make sure that we're working with all the code in our project. Then we set up node. We use the setup node action to get node set up in our environment. And we're specifying version 14. We then run a couple of node commands. So we have npm install, node package manager install, node package manager run build, which are just 2 node commands that we use in our workflow to install any dependencies and then build the project for our environment. Then our next step is called deploy to Azure, and we're going to use the action web apps-deploy, and that's an Azure specific command, web apps-deploy, and then we give it some with parameters. App name is e-commerce app. Then we have a publishing profile, and the package means just use everything that's included in the project. So this is the first version of our deployment script, and we can continue to use Copilot to help us refine this, add some more steps or add some new jobs, but we've got our framework here, and Copilot has helped us create that. And then finally, in step 4, we're going to automate some monitoring steps. We're going to go back to our deployment script here. We're going to, again, prompt Copilot and ask it to automate performance monitoring by setting up an alert rule for high CPU usage. So we want to add to this script and make sure that Azure can alert us when there's a high CPU usage in our app. So the first thing that Copilot would give us back perhaps is some variables. We've already got these defined, so we don't really need new ones. We've already got e-commerce app and e-resource group. So I'm going to just delete those. Sometimes Copilot will give you information that you don't really need because you've already got it in the script. So I'm going to go ahead and remove those. Then it provides the script that we do need for creating that monitor. So I'm going to go ahead and copy that out. Assuming Copilot gave us this code, we've now got our metrics alert create command here at the top, AZ monitor metrics alert create. And that's really what we need to get that alert created. So we run that command. We give it a name called high CPU alert. We tell it which resource group we're going to use. It's using this name for the resource group. Just always checking what Copilot provides. We would probably want to use this name because this is the one that's located in our variable lists. So we want to make sure we're copying those through in this setup. For scopes, we want to use web app show. We want to notice the CPU alert for that web app. We're going to specify that specific resource on Azure. That's how the alert will be triggered, is through that particular resource. So I'm going to go ahead and change all of my variable names so they all match. So we've got web app show to give us the location of the alert, and then we got some more variables here. So condition average percentage CPU is greater than 80%. That's when the alert will trigger. We'll get an alert that says CPU usage is high. That tells us something is going wrong, and then we can go in and check it. Window size is 5 minutes, which means it'll check every 5 minutes for that condition and then alert us if the condition is met. And then it'll evaluate every 1 minute. So it's going to look for that condition every 1 minute and then let us know every 5 minutes. Copilot helped us create this additional monitoring setup on Azure. And if we wanted to monitor other things like high RAM usage or errors with web traffic, there's some issue where users can't get to the website, the 404 errors or whatever, we can use Copilot to create alerts based on some of those metrics, and we can add them to this script. The script will run each of these items for us and create that environment on Azure. And then when we push our items to GitHub, then this workflow will be enabled. And anytime we push new code, then we'll get all these steps running.
As you've discovered, automation is crucial in modern DevOps workflows. Leveraging AI-powered tools like Microsoft Copilot enhances efficiency, reduces manual effort, and optimizes deployment processes, making software delivery faster and more reliable. We began by examining how Microsoft Copilot enhanced the creation of automated deployment scripts, using AI-driven insights to simplify workflows and improve efficiency in deployment processes. Next, we explored how Microsoft Copilot streamlined the development of CI/CD pipelines,
utilizing AI-generated scripts to automate integration, testing, and deployment while reducing manual intervention. Then we identified how Copilot can help debug and optimize deployment processes, identifying errors, improve efficiency, and ensure smooth application rollouts. Finally, we leveraged Microsoft Copilot to automate and streamline DevOps workflows, incorporating AI-powered solutions to enhance team collaboration, accelerate deployments, and optimize system performance. Enhancing deployments workflows with Microsoft Copilot improves efficiency, reduces errors, and streamlines DevOps processes. Applying these automation techniques will help you optimize software delivery and maintain smoother operations. Behind every efficient logistics platform is a solid system for managing inventory and tracking orders. In this project, you'll begin building the core of that system for Logitrack, where smart business logic meets reliable data storage. In this video, we'll explain key concepts related to structuring business logic and integrating a relational database for logistics software platform. Let's break down the programming concepts you'll use as you build your backend Capstone project. At the core of this activity is C#, the language you'll use to structure and organize your code. Here's a few things to keep in mind. Variables hold values like quantity or location. Methods define behaviors like printing or updating an order. Classes group properties and methods together so you can model real-world entities like inventory items and customer orders. You'll use object-oriented programming to represent each part of your logistics system as a class. OOP helps break down complex systems into manageable parts. It also organizes code using classes and objects. For example, an inventory item class could represent a physical product, while an order class handles customer requests. By designing classes that represent inventory and orders, your code becomes easier to understand and extend. In this activity, you'll start by creating an inventory item class. This class will include basic attributes like name, quantity, and location, plus a method to display that information in a human-readable format. Think of this class as a way to mirror real inventory data. When you call the display info method, it prints something like item, pallet jack. Next, you'll create the order class. This one models a customer's order and will include details like order ID, customer name, the date the order was placed, and the list of inventory items. The order class should include methods to add or remove items and generate a quick summary like order number 1001 for Samir. Once you've set up your classes, you'll connect them to a database using Entity Framework Core. This will allow you to persist your inventory and order data so it's not lost when the app shuts down. With EF Core, you'll define a context class and use commands to generate the database schema. You'll also use data annotations or Fluent API to configure your relationships, like one order having many items. Finally, you'll practice using Microsoft Copilot to review and refine your logic. Whether you're debugging a method or exploring performance tweaks, Copilot is a great support tool. You'll use prompts like suggest a way to print order summaries efficiently, then use Copilot's insights to refactor or improve your methods. This activity sets the foundation of your full order management system. By the end, you'll have a working business logic, database integration, and your first Copilot-powered improvements, all ready for expansion in the next Capstone activity. In a logistics platform like Logitrack, systems need to communicate with each other. That's where APIs come in. They act as bridges, connecting your application's logic and data to external systems through well-defined routes. In this video, we will review the concepts behind building API endpoints. You'll use these ideas to complete your inventory and order controllers in this activity. At the heart of every web API is the controller. They handle incoming requests and decide what happens next, whether it's retrieving data, saving a new record, or deleting an entry. Let's start by understanding what an API controller is. An API controller is a class that handles HTTP requests and sends back responses. It organizes how your system processes actions like retrieving inventory data or creating a new order, keeping your backend logic clean and structured. Once you have a controller in place, routing takes over. Routing is the process of matching an incoming URL to a specific method in a controller. It determines which code should run based on the request's path. Then, the HTTP method like get, post, or delete tells the controller what type of operation to perform, such as reading data, creating something new, or deleting a record. For example, the route /API/inventory is handled by the inventory controller. This route supports different operations depending on the HTTP method like get to list all items, post to add a new item, and delete to remove one. The order controller follows a similar structure. The route /API/orders is managed by the order controller. It includes a get method to list all orders or retrieve one, a post method to create a new order, and a delete method to remove an order by its ID. After the routes are defined, the next step is enabling controllers to access the database. Dependency injection is a design pattern where an object's dependencies are provided externally, making the code more modular, testable, and maintainable. It enables parts of the application, like controllers, to receive necessary services, such as a database context, without creating them directly. This allows API logic to retrieve data, create new records, or delete existing entries in a clean and efficient way. With services in place, the next focus is handling requests reliably, especially when something goes wrong. This is where async error handling comes in. Async error handling refers to techniques for managing failed requests and improving performance with asynchronous code. When a request fails, for example, if an ID doesn't exist, the API should return a clear and helpful response. Using asynchronous methods also improves performance by allowing the application to handle multiple requests more efficiently. Once the API logic is in place, the next step is refining and improving it. Handling requests efficiently is essential for a smooth API experience. But even well-structured controllers can run into problems. An endpoint might not return the expected data, or an error response might not be clear enough to be helpful. Finding and fixing these issues takes time. But AI-powered tools like Microsoft Copilot can suggest improvements, catch common mistakes, and streamline development. Copilot enhances development by identifying inefficiencies and suggesting improvements. It also helps refine route logic, generate missing endpoints, and ensure the API responds clearly and consistently, making development smoother and faster. If a controller method isn't using asynchronous code or lacks proper error handling, Copilot can recommend changes and improve performance and reliability. Imagine building a logistics system that tracks orders and inventory across multiple fulfillment centers. Here's how these concepts work together. The inventory controller structures how inventory data is accessed through routes like /API/inventory. HTTP methods such as get, post, and delete define what each endpoint does, whether it retrieves items, adds new ones, or removes them by ID. Dependency injection provides the controllers with access to the database, allowing each route to perform its operation without directly managing the database connection. Async error handling ensures that if a request fails or an ID isn't found, the API responds with helpful and efficient feedback. And Copilot supports development by suggesting better ways to write controller logic, generate endpoints, and improve overall performance. By applying these concepts, the result is a well-structured, maintainable API that serves as the backbone of a robust backend system. Modern web applications rely on clean controller architecture, efficient routing, and reliable error handling. Mastering these API development concepts allows applications to process requests accurately, scale effectively, and integrate seamlessly with other systems. In any web application, controlling access is just as important as handling data. Users need to register, log in securely, and access only the parts of the system where they're allowed to. That's where authentication and authorization come in. In this video, we'll explain key concepts related to securing API endpoints using ASP.NET Identity and Authorization. Let's start with the foundation, ASP.NET Identity. ASP.NET Identity is a membership system that handles user registration, login, and role management in ASP.NET Core applications. It handles the creation and storage of user accounts, verifies credentials during login, and supports assigning roles to manage what different users are allowed to do. This system enables secure access control without needing to build custom logic from scratch. Once identity is added to the application, users need a way to register and sign in. This is where authentication endpoints come in. Authentication endpoints are API routes that allow users to register for an account or log in. These endpoints also return a token after login, which the client can include in future requests to prove the user's identity. These tokens make it possible for the system to recognize who's making a request and apply the correct permissions when processing it. After a user is authenticated, the next step is deciding what that user can access. This is known as authorization. Authorization is the process of controlling access to specific parts of an application based on a user's identity or role. In practice, this is often done by applying the bracket authorize close bracket attribute to API routes. The system checks whether the request comes from an authenticated user and, optionally, whether that user belongs to a specific role, such as manager, before allowing access. This helps enforce security boundaries in an application. Securing an API involves many decisions: what routes to protect, which roles to define, and how to handle access errors. That's where AI tools like Microsoft Copilot can offer support. Microsoft Copilot helps streamline secure development. It can generate endpoints for login, add authentication logic, and suggest ways to restrict access based on user roles. With the right prompts, Copilot can speed up secure implementation and help reduce common mistakes in authentication or role-based access. Imagine you're building an order management system that handles inventory and customer orders. Here's how these concepts work together. ASP.NET Identity manages user accounts and roles, ensuring that only authorized users can access sensitive operations. Authentication endpoints allow users to register and log in, ensuring tokens that verify their identity with each request. Authorization attributes restrict access to certain routes, such as deleting inventory or viewing all orders based on assigned roles. Copilot supports this process by suggesting secure authentication logic and helping configure role-based access efficiently. This level of control is essential for an order management system to protect business data, prevent unauthorized changes, and ensure each user has appropriate access. By applying these concepts, the result is a secure, role-aware API that supports safe and efficient system operations. Secure APIs rely on authentication to verify users and authorization to manage what users can access. Combined with tools like Copilot, these practices lead to a safer, more reliable application. In this activity, you'll focus on optimizing the performance of your API. You'll apply caching, refine your database queries, measure your results, and even use Copilot to suggest improvements. Let's take a minute to review how each piece works before you jump in. You'll use these 4 techniques to boost your API's performance. Each one helps your app respond faster and use resources more efficiently. Let's start with in-memory caching. This lets your app quickly return data without hitting the database every time. It's like saving a favorite search so you don't have to type it in every time you need to search for something. It's faster for the user and easier on the server. Once the data is cached, future requests can grab it right from the memory. That cuts out the need to rerun the same query over and over. Next is query optimization. Instead of pulling in more data than you need or tracking changes you'll never make, you learn how to write cleaner, faster queries. .include helps load related data in one go, while .asNo tracking skips change tracking when you're just reading data. Both improve performance without changing what your app does. Of course, you want to prove your changes actually help. That's where performance profiling comes in. By timing how long something takes before and after your updates, you'll know what's working. You'll use simple tools like Stopwatch to measure response times. It's a small step that gives you powerful insights into the effects of your changes. Finally, you'll use Copilot to help you review and improve your code. You can ask for performance tips, suggest ways to clean up your logic, or spot repetitive queries. Copilot helps you think through optimizations with AI assistance. It's like brainstorming with a coding partner that never gets tired. You now have a solid set of tools: caching, smart querying, performance checks, and AI support. In this next activity, you'll bring them all together to lever up your API speed and efficiency. Let's get started. You're almost done. In this activity, you'll take your API system across the finish line. That means making sure critical data sticks around, testing how the whole system runs, polishing your code, and getting everything ready to submit. Let's take a look at the final tools you'll use. These 4 concepts will help you stabilize your system, validate how it behaves in the real world, and make it shine before submitting it. First up is persistent state. This means keeping important data available across multiple requests or even sessions. Whether you're caching info temporarily or saving it long-term in a database, persistence makes sure nothing gets lost in between. You can manage state with in-memory caching or by writing data to the database, whichever fits your use case. Either way, this ensures your app can carry data forward as users interact with it. Next is workflow validation. This means testing how the whole system works, not just individual pieces. From logging in to accessing data to handling errors, everything needs to work together smoothly. Try to think like a user. Log in, request data, and try to break things. Does your API still behave correctly? That's how you'll validate that the whole workflow is solid. Once your code works, it's time to clean it up. A Copilot review helps you find any leftover issues like duplicate logic, long methods, or inefficient code. You can ask for suggestions and polish things before sharing your project. Copilot can help you rework a clunky method or clean up your controller. It's your shortcut to getting feedback fast. And finally, you'll prepare a production-ready API. That means clean code, clear comments, complete documentation, and reliable behavior. You'll make sure everything works and that your peers can understand how it's built. A production-ready build is polished, functional, and easy to hand off. This is your chance to show you've got real-world developer skills and can deliver a clean working solution. These final steps, persisting state, testing workflows, refining with Copilot, and preparing for submission, are what elevate your project from working code to professional quality backend. Let's get started. Congratulations on completing this course. Let's take a moment to reflect on the core skills and insights you've gained from deploying applications in Azure to automating workflows and ensuring long-term application stability. We began this course by introducing deploying applications in Azure, highlighting how cloud services support scalability, security, and performance. From there, we unpacked essential deployment steps, reviewing security best practices, and outlining effective strategies for managing applications in the cloud. Next, you configured CI/CD pipelines with GitHub Actions and Azure DevOps, discovering how automation streamline integration, testing, and deployment. You also learned how to monitor and maintain these pipelines effectively, applying best practices to support consistent and dependable software delivery. Then we focused on monitoring and maintaining applications, highlighting proactive approaches for tracking performance, managing logs, and automating routine tasks in Azure. You also examined methods for ensuring long-term application stability and maintaining strong security over time. After that, you leveraged Microsoft Copilot to automate deployment scripts and CI/CD pipelines, gaining insight into how AI-powered assistant improves workflows, simplified debugging, and enhances the efficiency of DevOps operations. Finally, you brought everything together in a Capstone project, combining deployment, automation, and monitoring skills to build a fully integrated DevOps solution. With these tools and techniques now under your belt, you're well equipped to design and manage efficient, secure, and scalable DevOps solutions. Keep applying what you've learned and continue exploring how AI and cloud technologies can elevate your development workflows. Congratulations on completing the program. You've built a strong foundation in back-end development, mastering essential tools, technologies, and workflows that are key to modern software development. We began by exploring the foundational principles and practices of back-end development. You then examined how to plan projects, use industry-standard tools, identified strategies for solving problems through logical thinking, and designed algorithms and flowcharts to map out programming logic. You also implemented control structures and loops for repetitive tasks and developed modular code using functions and methods. Next, we examined how to set up and configure .NET projects in Visual Studio Code. You applied core C# concepts like variables, control structures, loops, and methods to build basic applications. You also used object-oriented principles to create modular, scalable code. You explored asynchronous programming, practiced debugging, and leveraged Microsoft Copilot to enhance code quality and efficiency. Then we explored the features of the .NET framework, compared it with .NET Core, and identified common libraries and packages in .NET development. You set up a .NET environment, created a simple web API with ASP.NET Core, and integrated OpenAPI for documentation. You also defined key C# syntax and examined serialization in .NET, while using Microsoft Copilot to develop, debug, and implement API code and middleware components. Next, we explored the features of Entity Framework Core, the structure of relational databases, and techniques for optimizing SQL performance. You set up relational databases, modeled data with EF Core, and handled data retrieval, transactions, and concurrency control. You also examined SQL syntax, advanced query techniques, and security best practices while using Microsoft Copilot to write, debug, and optimize SQL queries for practical database operations. Then we examined the features of ASP.NET Identity, role-based access control, and core data protection principles. You explored user registration, token-based authentication, encryption, and securing API endpoints. You also defined the role of JWTs and best practices for secure data storage while using Microsoft Copilot to develop secure back-end applications, write secure code, and implement authentication and authorization. Next, we defined key concepts in caching, query optimization, and scalability, highlighting their impact on application performance. You implemented in-memory and distributed caching, indexing strategies, and scalable architecture patterns. You also explored techniques for analyzing query performance, managing traffic, and balancing load, while using Microsoft Copilot to optimize both application code and database queries. Then we examined caching strategies, query optimization techniques, and scalability principles to enhance performance in .NET Core environments. You implemented caching mechanisms, optimized database queries, and applied scalable architecture patterns to manage growing demands. Using Microsoft Copilot, you fine-tuned code and queries, analyzed performance, and synthesized these techniques into complete projects that demonstrated improved efficiency and scalability. Finally, we explored the features and benefits of Azure Cloud Services, best practices for securing applications, and effective methods for monitoring performance. You examined how to prepare applications for deployment, manage and scale them in Azure, and automate routine maintenance. We also defined CI/CD principles and highlighted the role of monitoring and maintaining application health. Using Microsoft Copilot, you developed deployment scripts and CI/CD pipelines, enhancing and optimizing each step of the deployment process. The skills you've gained from designing scalable APIs to managing databases, securing applications, and deploying to the cloud are in high demand across the industry. Whether you're starting a new role or advancing your current one, you are now equipped to contribute confidently and effectively to real-world back-end development projects. Congratulations.